go. Hey, hey, ho, ho, heliocentrum's got to go. But there was more words to it, wasn't there? Like, no curve, no rotation or something like that, no?
No, I think that's pretty much it. Hey, 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 ho. Gotta go. I think you guys added more to it, possibly.
We spiced it up.
Yeah.
No curve, no rotation.
No curve.
This is my emancipation proclamation.
No curve, no learn. No rotations, got to burn.
Well, that was just terrible. How did you fuck up your own rhyme?
No rotations, got to burn. Hey, hey.
Hey, hey. Hey, hey, ho, ho. Heliocentrism's got to go.
They say no, no, no. Yeah, I mean, seriously, it does have to go. And obviously, we're at the forefront. We're at the spearhead. We are driving information into the minds of the next generation. And obviously, without us,
at the trailing edge.
Without without our input, obviously they won't be as
Hang on,
aware.
that sounds like indoctrination.
I hope you don't follow the example of Nathan going
Obviously,
to
they won't be as aware as they are obviously now. Obviously, they're asking questions from the internet. They look for ball earthers, especially. One thing is when a flat earther tells the general public the earth is not a ball, well, I'm sure there's someone out there smarter than you and me who can answer these.
No, they get fucking laughed at.
Yeah, they do. I mean, they come up to us and they say,
of course they do, because it's fucking ludicrous.
Yeah, but that should be the normal response. You should be like, haha, don't be silly. Of course it's not flat. That should be the regular, normal response. And then obviously you research it. And then you find out, well, actually, I can't prove we're on a ball. I have to literally...
Wrong.
I have to literally trust my government or institute.
Wrong. I don't trust my fucking government.
Wrong.
No, it's actually right.
Come on, guys.
It's actually right.
What the hell?
Right. Well, again, so we just go with what we were told. We accept what we're told, but not everybody does. We are out there to tell as many people as possible.
So you're trying to indoctrinate people to follow your belief system, then, are you?
No, not at all. What we're trying to do is raise.
What you just said is exactly the same thing you say about us, about drilling the information into the heads of other people.
No. Again, all we do is let people know there is no globe. If they ask for flat Earth model or anything like that, we can't provide it, obviously, because there's no model or map to provide, right? Obviously. So all we can do is just say, look, we're honest. Nobody knows what the Earth looks like. Nobody is gonna.
That's not
so, Kimo, you're basically saying, nah, I don't care about these millions of photographs. I don't care about these thousands of experiments conducted to provide evidence for gravity. I don't care about that. Nah, I have a claim, and I have no evidence for that claim, but you have to trust me. It's real.
It works with the public. The public like the honesty. If we start making things up and say,
Kimo, you're not honest with them at all. You tell them you've got facts and figures, and when people ask for them, you don't give facts or figures.
Oh yeah, we have the facts, the figures, the numbers. That is required. So, for example, if we can say,
where?
Well, for example, if we say the Earth is 3959, that's a figure. Yes, we can give them the facts.
At what location is that radius accurate?
We can give them the facts. And the facts are that the horizon's not physical. You know, we can go through all that stuff.
No, do you determine a banana by saying a banana is not an ananas?
No. What we do is we look for the radius value, yes. We allow the presupposition of that. If you want to beg the question, not a problem. But what we'll do at that point is go out there and try and find the physical geometric horizon, yes. And if it's not where you said it should be, then it's pretty much game over for the geometric globe, all that stuff. You understand, yeah.
Do you have some scientific experiments conducted to this topic? Because you have to take variables into account, please?
So 2 questions. How do you know where it is and was science conducted? Well, science was not needed in this question. And how do you know where it is? Well,
what?
that's the thing. We don't quite know where.
Kimo, how have you accounted for the variable
Another
of
question.
refraction of the
Have you
atmosphere?
accounted for refraction? So, again, we understand that if the horizon was in a physical geometrical location, then refraction would come into play, as in buildings would be seen more or less due to the refraction, the looming, the sharking, the shaking, the sinking, the simping, all that kind of stuff. And we understand that can only work with a physical geometric horizon, because you're not going to have something loom in front of your face, right?
Optical effects only work with the geometric horizon. Okay.
No.
Why can nothing else be affected? Don't say stupid shit like that.
No, come on, let's think about it.
You can't help it. You can't
No.
fix stupid.
No, let's think about it. If we see a
Kimo,
boat...
Kimo, you can talk as much as you want, but do you have some scientific experimentation, some data
Hold on, let
on
me just
that?
clear this up. If we see a boat looming, that's always at the horizon. It's never in front of the horizon.
No, it's not.
So it's either beyond the horizon,
no.
it's either at the horizon or beyond the horizon.
No.
Yes, never in front of the horizon.
You have no evidence of this.
Show a boat looming in front of the horizon.
No. I said you have no evidence of
Show
this.
me
You're
a
making
boat.
the claim.
You
Show
can't
me the
show
evidence.
it. You can't show it, can you?
Burden is upon you, my boy.
So that's how we understand how things are refracted.
Ah! Goalpost moved. Hand wave dismissal achieved.
It's not even that. It's not even related to the question he was asked.
Exactly.
Again, all we do is take your radius and we calculate the height of the observer.
Kimo, did anyone ever tell you you're a non sequitur?
No, people have said all sorts. That may have come across, but no, that I remember. No.
Don't bring Sort into this. He has nothing of the sort.
Well, he does have something to do with. He's a globe earther who believes that the Earth is
No,
spinning.
he's not.
Flying.
He's an idiot.
That too, and that's why he believes the Earth is spinning, flying through space, as it were.
We're not spinning. It's rotating, my friend.
Spinning, flying, turning.
Spinning denotes changes in velocity. You realise that, right?
Well, it's not moving. Full stop. The Earth does not move. It's motionless.
Do you have evidence of this?
Yes.
Do sunsets not happen?
Yes, we have. What did Bob use? Laser gyro.
I have a quote which says 15 degrees per hour turn.
Yes, so we saw 15 degree. That shows the stars are moving at 15 degrees per hour.
No, if you put this ring laser gyroscope on a toy globe and rotate the globe, it will pick up the same thing it did as you put it on the ground. How do you explain that?
Because the sky is moving around, yeah? Stars and
No,
stuff.
how does it
It
detect
had
what's happening?
motion on multiple axes, not only.
How is that gyroscope detecting what's happening in the sky?
Picking up the ether drift.
Can you prove that ether exists?
Yeah, we turn the machine on, we pick up a drift, we turn it off, there's no drift.
No. So that doesn't correlate to the
First of all,
ether.
no. It's not measuring the ether drift. If you're saying this, you don't understand how a gyroscope, a mechanical one, works.
Yeah, we get.
Or a ring laser
I
gyroscope.
don't think you understand. If you're saying it's the Earth that it's picking up, you're going to have to show that it's the Earth rotation is causing this.
I can show you. I take a toy globe and rotate it, and it will show
Of course
the
it will.
exact same thing.
Of course it will. You've got the 15 degrees of the sun and the ether.
There's two things there.
If
You're
you
going to have to
take
prove the
another
ether
object and
exists, and then
rotate
two, you're going to have to show how it detects anything that happens in the sky.
Well, that's what it's built for.
No. You know that's not true.
Detecting motion, dude.
About normal gyroscope, Kimo? You know, normal gyroscopes also exist, mechanical ones.
They're built to detect motion, right?
No,
Not of the sky, because
they're
the
built
implication that
to
you're
stay the same.
No, you can't pick and
Oh, you
choose
got
what it's detecting. Anyway, this everyone meet BioDuel. This is the guy who's going to conduct the Cavendish in a vacuum.
Kimo, you already made me come this morning. You don't gotta suck my dick again.
Everyone meet
Kimo,
this is
Kimo, I have
BioDuel.
shown you. Kimo, I have shown
People
you
are asking
an
people were saying,
experiment.
"Who's BioDuel?
Kimo.
Who's that?" And I was like, "Well, this
Kimo,
is the guy
Kimo.
who's going to do this experiment." Yes.
Kimo, don't you dare talk about gravity or Cavendish in a vacuum, because I have shown you, not Cavendish, but an experiment which has shown mass attracting mass in a chamber surrounded by mu metal.
False.
No.
No, he
No,
did.
stop.
He showed a
In
paper.
a
He showed a paper. Yeah.
Oh, so he
Yeah, I've
did.
shown you an experiment. Can I
Yeah.
continue? I've shown you a paper in a chamber surrounded by mu metal.
I know.
This shields against magnetism and stuff.
I
So true.
know. Not arguing
It
with
was
that.
done in a vacuum chamber and everything. So please, I have shown you mass attracting mass in a vacuum.
I know. We're waiting for the observed phenomenon, though. You think?
Mass falling towards another mass. Are you stupid?
Yes, we have the paper. We have the pictures. Okay, good stuff. Great. Now we're waiting for the observed phenomenon, so we can see the
Didn't-
mass.
I've told you. Are you stupid? You take a pen and you drop the pen. The
I
pen
know.
has a mass. You
Mhm.
said yes, it has a mass, and you said the ground below it has a mass.
Mhm.
There is my observed phenomenon.
The
Mass
problem
falling
with
towards
that
mass.
is that's just the observation.
That's the
You don't know why it's
that's
falling.
the effect. So drop the pen.
He asked.
You drop the
He
pen.
asked me about the nature of phenomena. I've
Yeah,
told him what it
I
is.
get it. I get it. And you're saying the cause is gravity, yeah, or mass, yeah.
No, I'm just doing the observed phenomena at the moment. You asked me for one. I've
All
presented
right,
it.
You've said it already. You're going to say it 3-4 times. Now, what's the cause of this pen
Then
dropping?
stop telling him he's giving you something other than he
All
told you he was
right.
giving you.
All right, what's the cause of the pen dropping?
So first, in the scientific method, if we use it, we make an observation. We've established that. The second step would be the hypothesis, and
Yeah.
this would be that if mass is
Mhm.
attracting mass or has an effect on other masses,
Mhm.
the masses placed near a pendulum would have an effect on it if a pendulum is swinging. So if you put the masses left and right, the pendulum would have a shorter swing period than if you place the masses in front of it and back in the back of it.
Are you talking
Like
about
in the experiment.
you're not talking Cavendish, are you?
Not Cavendish. I'm
No.
talking about the Hust experiment.
Okay. So again, have an effect. You want to know the cause. Hypothesize about the cause. What is your predicted cause to this effect?
The cause would be mass having an effect on other masses.
Okay, so you're saying mass is the cause.
Yeah, mass causes something that has an effect on other masses.
Right. How are you going to put this in a vacuum to test it, right?
Yeah,
Why does that
it's
have to be
shielded
in a
against
fucking
everything.
vacuum?
Vibration.
It's not required to be in a
It's-
vacuum.
It is a high. This was a high precision G measurement, so it had to get as low uncertainty factor of ppm, I think it's calculated in, and this number had to be as low as possible. So you had to take buoyancy, magnetism, and everything away.
Okay.
They isolated it, so it was only mass which could have an effect on the swinging pendulum in the vacuum chamber.
Okay. Yeah, no issue here. We need to witness this observation.
Hang on, so you're now
No, the
admitting that mass
observation you
attracts mass?
No, Kimo, the observation, you witness it every time. Mass falling towards another mass. And that's my observation.
I know
An
this is
observation
confusing.
I want.
This is slightly confusing. Okay, so let's try again. Object falls to the ground. Yes?
Yes, that's my observation.
Right. So we want to know what caused it.
Yeah, that's my hypothesis. I'm making a
Hold on,
hypothesis. And I
slow
said
it down, because we're going to get lost again. So we want to know what caused this effect. Yes?
Yeah.
Okay. So if I say to you, did magnetism cause this? You can say, well, no, because we accounted for that variable, right?
Absolutely.
Good. So you understand the cause and effect. If I say electricity, you can say, well, no, we accounted for that effect. Yeah?
Everything was accounted for. It
Right,
was,
right,
like I said.
right. So now we say we know the cause. Not magnets, not electricity, it's mass. But we haven't seen that cause in reality, in the vacuum.
No, we have.
Oh, we
That's
have?
wrong. This experiment was done in a vacuum.
Ah.
And we're following the scientific method. Step 1, observation. Have fun. We see mass falling towards the other mass. My hypothesis is that if mass has an effect on other masses, then we have to see a difference in the swinging period of the pendulum swinging if we place masses in different positions
Is this
the swinging pendulum.
this is Cavendish you're talking about, or not?
No, the Haast experiments. It's basically a torsion pendulum inside a vacuum chamber, and the masses have an effect on the swing period. Because if you put it left and right, the gravitational pull,
Yeah, it should work in
the
any
effect of these
direction.
masses will slow.
Yeah, I hear that. I mean, it should work in any direction. If there's mass,
So if you put it in,
what?
if you put the masses in front and in the back of this pendulum, it will swing longer.
Yeah.
Because it won't be slowed down. But if you put it left and right, there will be a slow pull, which will decelerate this pendulum. It's hard to explain. I can post the paper.
Don't have to explain it. Just show how it looks. Give a look at this.
Yeah, I can show you
Excellent. That's what we're talking
picture
about.
of the experiment.
Whoa.
So
a picture.
Yeah, of course. It's a picture of the chamber of the experiment. I can show you first
A picture.
how it was built.
Did you say picture?
It's a comic, and then I can show you picture.
Picture.
I can show you the scientific paper for this experiment too.
This is Cavendish in a vacuum.
Not Cavendish. Haast in vacuum.
How many times
And
does he have
this
to
is
say
the
it, Kimo?
apparatus.
All right, this is mass attracted mass in a vacuum.
Can you ask again if it's Cavendish?
I'm
Just
confused.
ask it again.
Extremely fucking
Kimo.
What is
boring.
going
Kimo,
on
I
here?
show you.
Oh my god! So look,
Kimo,
look, it doesn't matter. Is it mass attracting mass?
Mass having an effect on other masses.
Right. So we
Correct.
can say mass attracting mass. It doesn't matter if it's Cavendish or not, right?
Oh my god.
It's a different
Well done,
experiment.
He got there! Woo!
So the idea is that anyone, you can call it your name, whoever you want, but we want to see mass
Well, it
attracting.
depends on how you wangle it.
I've shown you that. Kimo, I've shown you mass having an effect on other masses.
He
At,
doesn't.
57 minutes, I posted
Why
you.
are you jumping through his hoops, man?
Right, Chris, you're interrupting a very
What?
deep discussion here.
Fuck off. Well, I don't have a voice.
You're triggered.
Is it all about you, Kimo? I thought it
You're
wasn't about you.
triggered, is what I'm saying.
I'm not triggered. I'm so triggered.
Why are you
I'm
triggered?
just bored, Kimo. Why are you triggered about me being triggered?
Because I'm about to
So you're triggered.
expose. I'm about to expose this guy about the Cavendish.
How can you expose something if you're
I'm not
triggered?
triggered.
It's
I'm
the Haast
excited,
experiment,
Chris.
first of all.
I'm excited.
I would like how he exposes me. I would like to see it.
I'm going to
I'm
expose him. Yeah.
excited too.
He wants to see me expose him. Yeah, you're
Yeah,
exposed,
guys.
Sam.
Go. Proceed, dickhead.
Sam, I'm going to expose you because there is no observation of this mass doing stuff with other mass, like you said.
Wrong.
vacuum.
The observation, my quote is, an observation is anything can be an observed phenomena,
You showed me a cartoon.
an problem, or an event.
Yeah, but
This is the first step of the scientific method, and I've shown you this observation. I have a mass, it's falling towards a mass. It's totally enough as observation. The observation is the easiest part of the scientific method. Einstein, for example, used a thought experiment. He thought how it would what effect it would have if he would ride on a light beam. And this thought inspired him to make his theories, to make his So the observation is absolutely easy, and there's no way we can argue about this for 15 minutes.
I'm
I
not
have an
arguing
observation.
about that. I agree. It's been done in a vacuum, but we've never seen it.
Sam, I'm
I'm
going to save you a lot of
stupid.
time right now. I'm going to save you a lot of time. What Kimo requires, because he's 7, is pretty pictures in the form of a video of the effect occurring. That's what he requires. So, yes, what you've provided is substantially better than what he's ever provided.
It's sufficient.
And they are legitimate experiments that people have repeated. There's a methodology. Yes, everything you provided is awesome. For Kimo specifically, he's 7 and requires pretty pictures in the form of a video.
Oh, you can ad hom. I've been ad hom
But
all
Kimo,
day.
I've shown you a picture.
You're under no
Kimo.
obligation to meet those requirements, though. You can
Oh, here's Veach now. Ad hom
I
again.
know.
Ad hom me all day. I've been ad hommed, right? And all I asked for was a simple observation of the masses doing what you say, and I get ad hommed for.
And
Yeah,
all I
I've
did
shown
was
you
not
that. I've
obligated to
shown you
meet your
that.
requests. That's it. So just relax.
No, he
They
says,
measured it.
Veach, we're having a discussion on mass.
Oh, ad hom me. Why don't you just ad hom me?
No,
Kimo?
you
All
are
your
ad
homs
homing
are
me.
So overwhelming.
You come in and said, "Oh, chemo."
I said, Kimo, you're not obligated to meet Kimo's request.
There you
That's all I
go.
said. So stop ad homing me. Oh my gosh, the ad homs everywhere, left and right. So many ad homs.
There you go. Why can't you
Name
just
calling
allow
each other.
the Globus to provide scientific evidence of the claim?
He has provided scientific evidence, and then you want pretty pictures in the form of a
Kimo,
video.
I've shown you.
Okay, so what we're
Kimo, I've shown you a picture of this experiment. This chamber in the background, this is mu metal. It's against magnetism and stuff. I don't need to explain it. And there you see how it's built inside the Hast experiment.
Yeah, I see the picture. I don't doubt the picture. But
So they didn't just write some nice little numbers down. They did this experiment. This is the proof for it. They have this apparatus, and they measured it, everything.
again, I understand this position, okay, but we still do not have the observation of mass attracting mass. We have a picture.
Are you talking about the first part of the scientific method, or like people said, like a video of this mass attracting mass having effect on
Okay,
other
so
masses?
again, we have the observed phenomenon. We need to know the cause. You're saying you know the cause by manipulating the independent variable in the vacuum. Problem is,
Absolutely.
we've never seen the independent variable manipulated, as in the air removed from the vacuum, and then see the objects move. We've never seen that before, ever.
Kimo,
Look, the dependent variable, Kimo, the dependent variable in this experiment is this swing period of the pendulum. The independent one is the location of the masses relative to the pendulum swinging.
No.
Yes.
No, of course not.
Why not? Why not?
Because that's
So,
not the,
tell me about it.
because that's not the cause to the effect, you see.
No, the mass of the the mass has an effect on the pendulum swing, the independent variable. So if I change the independent variable, which is the relative location of the masses towards the pendulum, it has to have an effect on the dependent variable, which is the swing period of the pendulum, and the pendulum has also mass.
Well, look,
And
go on.
we see a difference in the swing period. They measured it.
Well, I mean, even if that could even be accepted, if we had the observation of mass attracted, we don't even have the observation. So how can you say I know the cause if we don't even have the observation to the effect here?
Oh, that's absolutely wrong. They observe a difference in the swing period, and that means that they observe mass having an effect on other masses, and that means that my hypothesis is validated.
No one's
least
arguing
for
with
now.
any of that. Again, you're going back to what you said. Yes, they said they have a hypothesis. Yes, they said they measured something. Yes, they said they've done it in a vacuum. Yes, 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 all of this. But what we don't have, which is no, is the observation of the mass attracting mass in a vacuum. That's a no.
Are you stupid? I told you 5 times that we have one.
I know. I said yes, we have one. Yes, somebody somewhere has done this. Yes, they've written it
What?
down. Yes, they've showed the data to all the world. Yes, it's been peer reviewed. Yes, yes, yes. But what's no is there is no observation of mass, attracting mass anywhere by anyone at any time.
But Kimo, are you just stupid or are you pretending to be
Well, we're
stupid?
going to find
Honestly,
out. We're going to find
there are
out.
thousands.
Only one way to find
No,
out.
I can show you.
Well, show me.
I can show you 20 experiments on one website of the Royal Society.
All in a vacuum, yeah?
Which show mass attracting mass. I think most of them are in a vacuum because it makes it more precise.
What about 10? So most, that's 15 of them, yeah? At least.
I'm not sure. I haven't read all of them.
You said most of them. That would be around 15, no?
All it takes is one experiment.
No, hold on.
Oh,
it
God.
needs to be a high amount so everyone can hear that there's at least 15 experiments said to have been done in a vacuum.
No, Kimo, my point is that there are thousands of experiments.
Thousands, he's saying. Thousands.
No,
Thousands.
I wouldn't say thousands.
Thousands, he's saying, of cavendish
Honestly.
or mass attracting mass in a vacuum. Thousands, yes?
You know, college students do this every day.
Every day this is done. You see?
I mean, thousands of different experiments. Like
I don't doubt it. I don't doubt it. Thousands. Everybody's doing it every.
Means that there's a variation in them.
Yeah. Everyone's doing it every day. Get it?
Virtually alone, Kimo. You are virtually by yourself with this hypothesis that the atmosphere is causing it. Nobody else believes that.
Okay.
Nobody else knows it's mass attracting mass.
Nobody.
That's your claim. You're the one that needs to show it. You need to prove that Cavendish
It's not about whether anyone believes it. Nobody's seen
in a
it.
vacuum. It's your responsibility. It's not ours, Kimo.
So you keep saying it's
Kimo,
not my claim.
Kimo, could you please explain what's wrong with the experiment? Because I don't understand what's your point.
Nothing is wrong. Everything is perfect. But the only problem is we have not seen it.
Did you say nothing is wrong, but there's something wrong with it?
But nothing is wrong. Everything sounds perfect. The only problem is we need to see the observation, the natural phenomena of mass attracting mass in a vacuum.
But we see it.
No, we don't. No, we don't.
Yes.
Kimo needs to
See mass
clarify
attracting
what
mass without a vacuum all the time. We see it right here in our atmosphere.
We know what causes
We don't
that.
need to see it in a
We know
vacuum.
what causes that.
Kimo, do you know why they used a vacuum chamber? They used a vacuum chamber to take variables out.
Exactly.
Density, resistance.
Exactly. Talk to them, Sammy.
It
Talk
just
to
makes the
them.
measurement more precise. Kimo.
How blue?
You can look at all the
It was a
measurements that
high
were made.
precise measurement of
Look at
G.
the
They
Listen to
measurements
Sammy.
that were made prior to these vacuum experiments.
Listen
You
to
can look at
Sammy.
the measurements that
Blue.
were made prior to the vacuum
Listen
experiments
to Sammy.
that have about the same, roughly the same accuracy as my Cavendish experiment had, something within about a 1%. As soon as you start doing it in a vacuum, you get rid of some of these other random error type problems. The accuracy increases.
Listen to
And it's
Sammy
increased
here.
continuously.
You just keep on going on. Listen to Sammy. Sammy's saying the variables. Tell him, Sammy, why it's done in the vacuum. Tell him again.
Wait, what?
Why is it done in the vacuum? What's the reason?
I told you 10 times
You
now.
told us 10 times,
You have,
Blue. 10 times.
Did you lose your short-time memory?
Did you lose your memory,
I told
Blue?
you it was done. No. It was done in a vacuum chamber to get the
What?
get as precise as possible.
Exactly.
I not the word. Oh my god. They use ppm, pieces per million.
Right.
And if this number gets lower, it's more precise.
The point is, Kimo, it doesn't change anything to the cause and effect. What you're doing is getting a more precise value.
He said
But it doesn't do anything for cause and effect.
He said to account for variables.
Right, you account to get to a more precise value, not to change the value, not to manipulate or come up with a wildly different number.
Okay,
to a
fine.
more precise value, Kimo.
Fine. I'm not even arguing with
No,
that.
you can get
I'm not
little
even
variables
arguing with that.
anyway.
I'm not even arguing with that. Fine.
You
Show
can
it.
get a little.
Whatever it is, show
Okay,
it.
come on.
Whatever the reason, show the observation. I don't care about the reason.
We
Just show
don't
it.
need to show it, Kimo. We don't need to.
We've had
You
different
need to.
reasons from
You're the
Blue,
one that needs it, not
from
us.
Bio.
Kimo, I understand. I
From
don't
Sam.
understand what your fucking point is at the moment because I've shown you an
Oh my
observation.
God.
I've shown you the experiment. I've shown you multiple other experiments. I can show you.
No. I don't want to read a paper. I want to see the experiment that was done go on the paper? What did they write? What did they see to write down on the paper? Let's see what they saw.
They measured the swing period of the pendulum. It is shown they can do it.
He wants to see a video. He wants to see a video. That's it. That's
Okay,
the
Kimo, if
result.
it's your personal opinion, I don't care. We're talking about
Well,
science
again,
right now.
if you don't care, you'll care when we tell the next generation that they have no gravity, they have no mass attracting mass, they didn't count for the variables, they deceive the people, they deceive the world, they don't know what gravity is, there is no... So all of that stuff will go hand in hand. You need to be able to show that there is an attraction, so the next generation can do science in the right and correct way.
Yeah, I've shown you like 1,000 scientific experiments. I can show you them.
He only wants to
I
see.
know. I'm not doubting those papers. How many times? Got paper on paper, thousands all over the world, every single day. It's being done.
Stop doubting the
Yeah.
papers, Chemo. The papers are real.
Okay, not doubting them. Not doubting them. Fine.
Okay, well, so you agree with him. You agree.
No, I didn't say I agree with them. I agree
You
that
just
they've got...
agreed. You just said you don't doubt them.
How the world works.
I don't doubt, Veach, we've got the papers. I don't doubt that. I don't doubt people are saying we've done it. I don't doubt any of that. What the cause is.
If you don't doubt the papers, then you don't doubt the results. Then you know it's true.
I didn't say any of that. I said I don't doubt...
Yeah, you did.
Chemo.
Of course you did.
Chemo, you know that they don't like put videos in paper.
Right, exactly.
So what
Never
you're
been
asking,
done that I know of.
what you're asking
So the
for
main...
is
Sorry.
to witness
Mhm.
either firsthand or a video of the experiment being performed.
Mhm.
Is that correct?
Yeah, I mean, again, if someone's making a claim, we've got to show, we've got to see it, the observed phenomenon. So, yes.
You're just reiterating my point for me. Thank you very much.
That's
So,
what we've
in
been-
your mind,
Mhm.
if the video doesn't exist,
Mhm.
it isn't real.
We don't know yet. We don't know. We're here to
How
find
do you
out.
know that you need a video, Chemo? How do you know that?
How do you know
No,
what?
he's saying people
Hold
are
on, what did
lying
Veach
is what
say?
he's saying.
What did Veach say? What did you say, Veach?
How do you know that you need a video, Chemo?
Because we have lots of information that suggests mass attracts mass, but we've never seen this.
It's an interesting claim that you're making
No.
about needing a video. Do you have a video that we can look at that shows us that you need a video?
Well, no, this is a scientific claim, Veach, and obviously,
No,
if
I can't. It's just you're making this claim, and I don't know whether it's true or not until I see a video of it. So I need a video that will show me that you need a video.
well, again, if a claim like that is being made, then yeah, sure. If you need to see that, then yeah, that's
Can you present that, please? Could you present that?
Or Chemo,
it's not science,
you can
Veach. It's not
perform the
science.
experiment yourself.
Well, I need this video.
Okay, this
otherwise I don't know
conversation
that
is
what you're saying
stupid.
is true.
Can you stop interrupting Veach? Veach, that's not science.
But if you don't show me a video, I don't know if it's true. If I don't see you actually showing me proof that you need a video,
Yeah, but that's a shitty false analogy.
Yeah, but that's just an opinion,
No,
Veach.
it's not. You can also ask
Oh,
what
that's
step
an
of the
exact analogy.
scientific method
Veach.
requires a video.
Veach, that's just my hypothesis. Yeah, so or at that
That's not a
stage, we don't need to
hypothesis,
see.
that's your
We don't need to
conclusion.
so what you're
see
saying is not true then.
about what.
Well, that you needing a video.
No, what's not true is that mass attracted mass in a vacuum.
But do you
No,
need
no.
a video
Prove
in order
it.
to know something is
Hold
true or
up.
not?
Okay, Kimo, let's
It's
follow the
okay.
scientific method. Kimo, let's
They
follow
keep
the scientific
interrupting you,
method.
Veach. It's like they can't hear you or something.
No, Kimo, the scientific method. Okay, first step, the observation in nature. We can use an event, and problem, or a phenomena. Yes?
Yeah, I'm down with that. Yeah, that sounds good to me.
Good,
I can
perfect.
work with.
I just take
that.
a
Yeah.
cap, a pen, or anything, and I drop it. I know that this pencil or pen has mass, and I know the ground below it has mass. So I think to myself, I think this mass has an effect on other masses. That's why it's falling down.
Good. Good.
Then
Nice.
I need to make an
That's your
hypothesis. I need to.
hypothesis.
That was my yeah. Basically, I'm now going to my.
Now remember, your
like I'm
hypothesis
thinking
is
about
hold on. Your hypothesis is your predicted cause to this effect. Okay.
Yeah, of course.
Okay, go on.
So I'm thinking, if I have a pendulum swinging, and I place masses left and right of it, I want to use the right vocabulary now, left and right of it, then it will swing, the swing period of this
Skip to
pendulum
step,
will be
but go on.
shorter than if you put it in front of it and in the back of it, because that's how stuff works.
Yeah, but you've skipped.
You can do
a
it with
step.
magnets too.
You've
but-
skipped a step though, Sammy. haven't given me.
Yeah. So which one?
Yeah. So you haven't given the predicted cause to the effect, right?
I've told you my hypothesis, and now I make predictions. My
No, your
predictions
hypothesis is your predicted cause, and then what you gave the experiment before the predicted cause. So don't tell me what you're going to do. Don't tell me what you're going to do. Tell me what you think caused this object to fall.
So cause in my hypothesis is mass having an effect on other masses, or mass causing something to have an effect on other masses, and
So your independent variable
effect is the pendulum swinging different.
No, again, you're jumping ahead. Your independent variable is mass, yeah?
My independent variable is the position of the mass in this experiment.
The position.
It can be three things, Chemo. It can be either one of the masses, and it can be the distance between them. Pick any one of those three.
But that's still the
independent variable.
But that's still the effect, though, in this situation.
No, Chemo. The position of the masses and the size of the masses that's what you get to choose. That's the independent variables.
No.
That's
the effect. I'm trying to figure out what caused this.
That's not the effect, Chemo. You get to pick the two masses and the distance between them, Chemo. Those are the independent variables, the possible ones. You keep two of them constant as control variables, and you vary the third one.
No, but there's only one independent variable.
Yeah, Chemo. Chemo, every fucking experiment has multiple possible independent variables. We call them control variables. The ones that we don't want to mess with, we just fix in one position or at one value.
Yeah, again,
Do you not know what a control variable is, Chemo?
That is pseudoscience.
Do I need to educate you about this?
Chemo, have you ever?
Look, there's only one variable that
I've
will
seen
cause.
a picture where Chemo was behind a camera.
There's an independent, dependent, and control variables.
Okay, so the control variables, are the variables that you think are a cause, but then if they're not the cause, you're going to keep them what you think in a static position. So
are you trying to reword what Blue said and failing miserably?
So your effect can only have one.
That's what he's trying to do.
Your effect can only have one cause.
Hold on, Chemo. You just told Chemo, stop. You just told Blue that he was wrong when he described exactly what you're describing. Why are you trying to reword it to sound like you're not saying exactly what Blue said?
Blue said there were two independent variables. One.
I did not, Chemo. You misrepresenting what I said. I said there are three things that could potentially be independent variables. You only want to change one of them. You never change two. Only one. So you pick the one you want to play with, and you fix the other two. They are then control variables.
No, that's not a scientific experiment, Blue.
Every single citation will agree with Blue.
Check it out.
I mean, even Quantum Eraser would agree with that way of putting it.
So, Kimo, in my experiment, the independent variable is the position of the masses. One control variable would be that the mass of these lead balls or stainless steel balls doesn't change. It always remains the same.
Well, again, you have an effect, and there is one thing that causes this effect. And that's what we're trying to predict is the cause to that effect. Now you're saying,
what's a control variable?
You're saying that the mass is the cause of this effect of the attraction. And I'm saying, I'm saying just as well as other people it could be electricity. You said you ruled out. It could be magnetism. That out. And then now Sammy here says that in a vacuum there are other variables like the atmosphere or air, and we haven't seen that yet. That's what we're looking for.
A vacuum isn't required to keep the atmosphere at as a control variable. You don't require a vacuum.
Well, it's a variable that causes the effect that we observe. So
it would cause it. It would cause it if there was a deviation in air pressure, but a vacuum is not required to prevent deviation of air pressure.
I want to mention this vacuum chamber.
What will have an effect on it is the movement of air. That's what they're trying to eliminate. But you only get a result that's about less than 1% better than if you don't worry about it at all. It changes really nothing.
Not to mention that by bringing it to equilibrium, you have eliminated air as a cause. Not to mention that very specific point that you seem to always forget, Kimo.
Well, again, we will only know this if we manipulate that variable by removing it in.
That's manipulating the variable.
No.
By placing it into a vacuum chamber, you have effectively manipulated a variable.
Yeah, once it's in the vacuum. Once it's in the vacuum, then yeah, we've controlled that variable, but never seen mass attracting mass in a vacuum.
You mean you haven't seen a video? Please complete the sentence. You're giving an atrophied sentence because you're being an asshole. It's you haven't seen a video of it. Just say the words, man.
No. Nobody has ever seen mass attracted mass in a vacuum.
Video.
No, they measured it, Kimo. Just because you don't have a video doesn't mean it's
He's just
wrong.
going to go around in the same circle.
No, it's stupid.
Well, it's not my claim. You claim there is a force of mass attracted mass, but there is no experiment.
No, I don't claim.
We've proven that.
No, Kimo, we have measurements. They measured it.
You're claiming that the atmosphere causes it. Kimo is claiming that the atmosphere is what causes it. It is Kimo's claim to support with an experiment.
We have the experiment. We already have it.
Show us the Cavendish at atmospheric pressure, Kimo. Then remove the atmosphere and show us it no longer works. That is your responsibility, not ours.
Why are you keeping saying that? We have Cavendish in a vacuum already. You already have it. We already have it.
Fine.
You're saying that an experiment can't be done more than once, Kimo?
Well, 1,000 times we've been told.
That you can't verify by doing the experiment or invalidating others' results in their experiments by doing it yourself?
We have it.
Because that's what it sounds like you're saying.
It's been done
You're saying that so take your pick. Either you trust the experiment that has already been performed and the paper that's been published on it, or you don't trust it and therefore need to actually invalidate it because that is your hypothesis that it doesn't work if a vacuum is been done. Saying that it hasn't been seen doesn't stop you from doing it yourself.
Again,
it's not just one person or one lab that has done this. It's been done over the past 90 years or so in vacuum chambers, over and over again by a lot of different organizations, and they essentially always get the same result.
We know. We're not.
It only changes the value out in the fourth and fifth decimal place.
We know.
First three have been set for years, Kimo.
Again, every day it's been done. It's been done over many, many years. We know, but nobody has ever seen it.
Everybody that did it has seen it, Kimo.
Everybody
that did it saw it.
Wait, how did they not see it?
Don't
say what they saw.
Don't just make this stuff up.
Go on, then let's see what they saw. Go on, then let's see what they saw.
How did they not see it?
Well, let's have a look at what they saw. Let's see what they saw.
That's what you see. That's what it boils down to. Again, just say.
You see,
you want a video.
I want to see what they saw. Let's have a look at what you saw.
That's very easy, Kimo. We could give you the measurements because that's what they saw. That's why they jotted down the measurements.
The measurements, yeah. So you got something written down. The measurements.
He doesn't.
They got the results. They got the swing period of the pendulum. That's totally enough.
Okay, so they wrote something down. The measurement. Great.
Okay. Kimo.
Here, look.
Okay.
I posted a picture in chat.
Yeah, they wrote something down, just like in the Bible. Yeah, they wrote something down.
I write something down too.
Yeah. So you bring up the Bible because that kind of destroys your consistency. Is that you take the Bible's word for it without verification of other sources.
On
you
faith.
Just take the Bible
on faith.
Yeah,
that's right.
That's
That's
fine.
religion.
But now
that's
you're
right.
inconsistent with
so you agree? You have a
verifiable,
religion.
repeatable experiments.
Okay. You agree. You have a religion.
No. I was just trying to finish what I was saying. I'm sorry that you're a moderator that was speaking over me. That's my fault.
Well, I'm just saying you agree. Then you have a religion.
No, because there's a key difference. Because when I brought up the Bible, I said that there's no verifiable evidence from any other source. It's just the Bible self-circulating its own truth. But when it comes to scientific papers, they're verified through other means by people all over the world conducting these experiments at different times, and they are trying to prove each other wrong or trying to become more precise. It's almost like a competition for this to occur. There's every reason for them to invalidate someone else's experiment, but they don't. They validate each other because it's a consistent experiment with a methodology that you can repeat yourself.
Fair enough. Go on then. Let's have a look at these experiments. Then let's show them if you're not like the Bible.
Why don't
Hold on a second. I want to respond. He just went on. So, if it's not like the Bible, where there's nothing in the Bible that can be validated and verified, show your experiment of mass attracting mass in a vacuum. Show that it's not just on paper or in a picture. Let's have a look.
Just because you move the goalpost doesn't mean that.
So there's no difference then. There's no difference.
No. Just because you move the goalpost doesn't mean that your argument is valid, Chemo. Because we can move goalposts if you want, but there's no goalpost for the Bible because there's no methodology, there's no instruction, there's no way to verify any of it. It's only claims without a methodology. Scientific papers give you claims, results, measurements with a methodology.
Okay, so let's have a look at the evidence.
And they also explain how it's done.
Let's have a look at the evidence of that then. Let's see someone who's repeated this methodology and shown mass attracting mass in a vacuum. Let's have a look.
I've shown you the experiment.
Can't because it's just like the Bible.
Saying, it doesn't work. No, Kimo. The Bible's problem is it isn't falsifiable or repeatable.
Yeah, it's just the word of God. It's just words. It's just words written down. Yes.
Okay, guys.
No, Kimo.
This is what y'all keep running into the same wall. He doesn't care if it's written down. He doesn't care if there are photos taken because apparently he doesn't understand the difference between a photo and a bunch of photos in a series because he just wants to see a video, period. There's no other way around that. And if there's no video out there that anyone can find, according to Chemo, it's all bullshit.
Wow.
No, of course. He's not going to spout his bullshit.
You've got to ask yourself why there's all this...
I want to see a video of Chemo's birth. I demand it right now, otherwise he was never born.
No one's written about that, but they've written about this mass attracted mass for thousands of years or thousands of experiments, you said, that happens every single day, you said, but there was not one observation of what's been written about every single day for thousands.
People observed it. These people observed it. If you're saying, no, they didn't, you're just lying.
Okay,
you're saying
I didn't say that. I didn't say that.
lying.
I didn't say that. I said, show me what they saw. Let's have a look.
As soon as you tell us what step in the scientific method requires video proofs, then get back to us.
So it's the same as the Bible, then, yeah. So if I say Jesus walked on water, you just believe it because it's written down, yeah.
I would ask for a methodology.
Yeah, I've just told you become light. Okay, pray, fast,
of it describes how they
transform into light, bio, and that's how you can walk on water.
Page 29.
Hold on, he's just going to say it's like chapter and verse. Chemo, if you doubt the
Bible, if you doubt the Bible, then what?
I don't care. I don't give a shit about the whole Bible argument.
Look, the point is, what's the difference?
Hold on. You want to witness firsthand these experiments. There is only one way to do that, Chemo. Do you know how that is?
Yeah, that's to get an observation. Someone who claims this can show this. Yeah.
Already. No. Your problem is, I already said this. You want to witness it.
Nobody's witnessed it. Who's witnessed it?
Not
one person.
Whether or not you say no one's witnessed it means nothing to me.
Well, show me one person who's witnessed it. Who's witnessed it?
I don't need to show you anything.
Nobody has witnessed it.
Oh my god.
Now he wants the name and address of the people doing the
No,
research.
yours wasn't in a
about it.
vacuum, Blue. Yours was outside of a vacuum where we know the cause to the effect. Now, there was not
We
one...
don't need. It doesn't need to be in a vacuum. I don't need that level of accuracy.
Yeah, Blue. Look, we've
I'm
done it in a
within
vacuum.
1% of the value.
Blue, we're
You
going
will
to
still
argue
get
about your
similar
one.
results.
what-
They
I know
will
exactly
just
what
be
caused
not
it.
as precise.
Oh my gosh, breaking down. Now
Hold
look,
on,
we don't
Blue.
even need to talk about Blues because we've got an advanced version of Blues in a vacuum already been done thousands of times.
We don't need it. We don't need it to this.
What are you talking about?
We don't need the
it?
accuracy, Kimo.
I mean, we don't need
We're not
it.
looking for the accuracy. I don't care about that.
Well,
all I need is to get within one.
Unless you can show in a vacuum,
Yeah,
then
that's all I
your
care about.
experiment
And I
is we know the cause for it already.
I'm not trying to restate the actual the current value of G. That's not what I'm trying to do. I don't need that level of
Trying to
accuracy.
show
There's
there's
no
a
reason for me
force.
to do it in a vacuum.
Trying to show there's a force that's mass attracting mass.
We're still in
Yeah,
this
I showed
fucking
that.
Cavendish shit. Jesus
I showed that.
fucking Christ.
At least mass having an effect on other mass.
Kimo,
That's how it works.
Kimo just said he knows what the cause is.
Yeah, he claims it's the atmosphere.
What about the
Makes
one?
the
It's
claim.
the air pressure, the
no
air
result.
inside the
There's-
container. Yes, that's correct.
Wait,
okay. There's plenty of papers that produced a null result with that experiment, and you know what they did? They deleted them.
What you say? Sorry.
Hold on.
Say that
There
again.
was plenty of experiments. There was plenty of experiments done. This mass attracts mass, and they got a null result, and they deleted them.
Where? Where's this? Astro King. Welcome, Astro King.
Where is it?
Hey, Astro.
Hello, well.
Welcome. Is that in the vacuum chamber you're talking about?
Don't know, but they deleted them. So
We
you
don't
can't
need a
find them.
vacuum chamber.
We need the vacuum chamber because what we're saying is that in a vacuum they will not move because there's nothing to cause it to move inside the vacuum.
No, but it's moving.
Incorrect.
I've shown
Kimo,
you
you're just
in
throwing shit
experiment.
against the wall, coming up
No.
with some sort of bullshit.
Oh no!
Wait,
Again,
Kimo,
go on.
No.
No, he's doing.
Kimo, how you said that because the air, because Blue did something, it's closed off in a box or whatever,
Oh my gosh, even worse. Go on.
protected from air currents. So I'm just curious, what would cause what about air? What's special about air that would cause the balls to move specifically and proportionally?
Oh, you done?
Yeah.
Yeah, Kimo, why don't you answer why when he moves the weights, the thing turns the other direction? So how come the air reverses it when he moves the weights?
Yeah, I mean, look, any movement, any pressure that is in that chamber can only be down to pressure already in that chamber. Now, if you remove
What
that
pressure?
the pressure that's inside the box,
Hold on.
so you've got a gradient.
No.
Got a gradient.
What chamber?
You've
Did
got
I do
your,
that?
you've got
I
your
didn't change the pressure inside
got
the
a
box,
chamber.
Kimo.
the
I
container,
didn't
whatever it
change
is, the
anything about
container,
that.
the chamber, whatever you want to call it,
That didn't
You mean the
change.
garage?
the
No,
box, whatever you want to call it, whatever it's enclosed in. Okay.
Hold on. Kimo,
Yes.
real quick.
Yes.
If I have a jar,
Mhm.
right, on my counter,
Mhm.
and then I put the lid on,
Yes.
everything else is the same, right? All I did was put a lid on it.
Okay, so you've now trapped the air inside. Yes. Continue.
Right.
Right. Continue.
Did that increase the pressure inside?
To increase the pressure.
Yes.
But does that air?
Is there
This is so boring. I want to fucking top myself.
is there a change in the pressure by just putting a lid on it?
Well, we'd be able to weigh that air, wouldn't we? So yes, it's creating a
That's
pressure.
not an answer.
Well, yes, I'm giving the answer yes because we'd be able to weigh it. So therefore, there is pressure inside.
Wrong.
So wait.
Go on.
So if I weigh the lid separately, if I weigh the lid and
Pay
separately
attention,
from the
Blue,
jar,
to this, and all you guys.
and-
Go on.
and then
Gonna mess himself up, but carry on.
and then I put the lid on the jar,
Mm-hmm.
you're saying that the weight will increase
You're gonna trap.
more
You're
than
gonna
the
trap the air.
combination there of the weights.
Yeah, you're gonna trap the air. You're gonna have inside that jar gas pressure bouncing off the walls. Yeah.
I'm not talking about gas pressure anymore. You're talking about
Yeah,
quantity
you
there.
just said pressure. You
Inside
didn't
the
say gas. You just said pressure.
Yeah, gas pressure inside the container. That's what's giving you the pressure. Yeah, you've trapped air. Yeah.
No. You said no. I didn't say anything about gas pressure. You said pressure.
Yeah, that's where the
'Cause
pressure
if I
comes
fill it- 'cause
from.
if I fill it, okay, by that same consequence, if I fill it with water all the way to the top, right, where there's no air, there's no air space, and I close it, have I created pressure inside that jar?
It's not a gas, so no.
Kimo, can I ask a question quick?
What's the difference in this scenario between
It's not a gas.
Oh,
a
they fucked
jar
that
filled
son of
with air and a jar filled with water?
Yeah, gas creates pressure. Water. Well, the water will have a certain pressure off the air container, but it have water pressure, right?
Can I ask a question?
What? Okay, so what would be the effect of releasing that pressure?
Beard, you're kind of like annoying everyone with this line of question.
Yeah, because you can't answer exactly.
I'm
We're annoying
through
you.
the logic.
No, not me.
All
I
I'm
don't
doing-
mind, but he's
He's not annoying anybody, Kimo. Just answer the
Kimo, if I have a pressure gauge and I put it in the bottom of the jar, what does it say? It reads, I don't know, 14.7, right?
14.7. That's supposed to be
Okay, so if I put the lid on, does it change?
It depends if you trap the air.
No, incorrect. It doesn't change. It stays at 14.7. That's what he's getting at.
Is that because of a downward bias?
No, yeah, exactly. That's the downward bias called gravity, the one that contains the atmosphere.
So you'll have a gradient then. As you get higher, it increases. Yeah.
Yeah, exactly. And that's observable. Well, let's go back to the point. So this is the question he's trying to get you. If you put the lid on, nothing changes.
Yeah, but is there a gradient inside that jar?
A little bit, very small one, very, very small, probably immeasurable.
So there's more pressure at the bottom than there is at the top.
That's correct.
Well, there you go.
So what's the problem?
That's going to cause the movement. You've got pressure in there.
No, incorrect.
You just said there's a pressure gradient in there.
Yeah, but very, very small, almost insignificant. You probably can't measure it.
Well, that's what the Cavendish does. It's so significant.
No, incorrect. The Cavendish is one level. Sorry, wrong.
You just said it's in
Plus, it's in a garage. It's in a building. No, you're incorrect.
Exposed.
You're totally incorrect.
Busted.
You just throwing shit against the wall.
Busted. Because you just said there's a slight gradient of pressure in there. That means Cavendish only needs a slight detection.
No, incorrect.
Start
but these don't. The Cavendish measures it in the horizontal direction, not vertical.
Busted.
You complete idiot.
If there's a slight variation of pressure inside that container,
no, the pressure is the same. Sorry,
you
incorrect.
Just said
there's no. This you're not. I'm not. No, Kimo, you're totally wrong in this. Admit you're wrong and move on.
You just said there's a slight gradient in there. There's a slight pressure in there.
The pressure doesn't change when I move the lead balls. The pressure doesn't change.
Okay,
fine. How come when he moves the lead ball, it goes the other direction? What happens? Nothing changes in the pressure.
Well,
so why
balance only responds to the position of the lead balls. It doesn't have anything to do with pressure.
Okay, so why in a vacuum then it doesn't work?
It does work in a vacuum. They have a demonstration of it. They posted one the other day. Didn't you see it? The one with the what 90 nanograms.
Go on then, let's have a look.
Oh damn it! I have to do everything for you. You can't even follow the frickin' news.
So, like I said, the reason why it doesn't work in a vacuum.
It does work in a vacuum.
There is no pressure to push. There's nothing to push and to press the Cavendish.
No, incorrect. This is also, you guys don't understand this. You don't understand rockets for the same damn reason.
As long as there is pressure in that container, of course.
Here it is. Here, look. I found it for you since you're too lazy. How long did that take me?
Not that this is going to do anything, but Kimo made the claim that they don't work.
What's the timestamp?
You just let him slide on that.
No, I'm not going to slide.
No pressure to show it not working in a vacuum, as he claimed.
What's the timestamp?
Here, I proved
let him go and immediately assume the burden of proof that he just, you basically, he didn't even put it on you. You took it.
Whatever.
You blow my mind sometimes.
I'm showing him wrong.
All right,
He's
I'm looking
wrong.
at your link. I'm looking at your link. I'm looking right now. What's the timestamp? Where's the timestamp? Timestamp page here, NASA. Where is it? The timestamp.
10 March 21. Right at the top, where it belongs, and then right above the person that says "bye."
Okay,
under
so
the
now I have two experiments on the big screen. Both pictures. No observation of mass attracting mass. Again,
no, that's exactly what this proved. You complete idiot.
Again, a piece of paper with a picture that proves that we can see mass attracting mass.
Yeah.
Great.
Why don't you do the freaking experiment yourself and prove it yourself?
It's not my
You think that they just...
It
is your claim. Claim that it's false. It's your claim that it's false. Prove that it's false.
No,
Hey, Chemo, you know what you ought to do, Chemo? Just have them, something as simple as showing us where they got the 14.7. Let's see an experiment where you get 14.7 psi of atmospheric pressure. Just put it in the chat right now. It should be very simple to find. 14.7.
You find it then. I'm tired of you sea lining me. You find it.
We don't want to hear about your barometer either. Let's see how you originally did it.
With a barometer, with a mercury barometer. Very well. You know the answer. Good. You're wrong. Shut up.
You would have had to put the lines on the barometer. You would have known. There's no way for you to know how many pounds of pressure there is.
Yes, there is, you idiot. You calculate from the millimeter of mercury or the inch of the feet of water. That's how you do it. Are you to plead? Blue, you tell him. I'm going to lose my temper with this guy.
Before Sally did this, Jesus Christ.
So tell us
measure it with in any dimension you want to measure it in. Measure it in inches. You can measure it in millimeters. Do it any way you want to. You get the Jesus Christ. It's called a Torricelli mercury barometer. Look it up.
Just show us how the original, the very first, like Cavendish, there would have been somebody that went out before mercury was discovered and said, okay, this is 14.7. We all know what they did.
They did it with water.
They stuck a tube 33 feet down, just like your Mason brothers, and then they pulled it out, and then they figured it out from there, right? Be honest.
David, this one I think you can't be any stupider. You are stupider.
Be honest. How was the very first?
Right there. Right there. How long did that take me?
How was the very first experiment done that gave you
There.
your?
I just showed it to you. I posted it in chat.
Let's.
It really is fascinating.
Give us a real quick synopsis of what that says, Blake.
Oh, for fuck's sake!
It's fantastic to see how.
What's fantastic?
Let's cut out. It's fantastic how people think that their own ignorance counts as an argument, that it should be taken seriously. It's fascinating.
Well, again, this the next generation are on the line here. You're not getting it, are you? You think this is between like me and you, or this local community? No, we are looking to change the minds of a nation, and that's why there should be a flat Earth in every country. They can help to raise awareness in that country. Obviously, if there was no,
we are science. We are science, right, Chemo?
Well, there you go. Obviously, if there's no scientific evidence to support your side of version of events, then the next generation need to know this. If it's just written down on a piece of paper like the Bible, well, then what's the difference between your Bible and the Bible, the actual main real Bible?
Chemo, let's do.
But we're gonna bring new science, Chemo.
Let's do a quick ignorance test.
How was gas pressure first done to prove that there was 14.7? When and where was this 14.7? It was done with water. Now, was it done with water?
Hold on. Chemo,
it was done with water, measuring water in the air. That's all it measures. There is no pressure. It's measuring how much water's in there. Wake up.
Settle down, man.
Chemo,
I'm concerned for your personal safety, David. You got to quit letting the powers to be know how much you know. Okay? Keep some of this to yourself, David, for your own protection.
Let's ignorance test all of us.
Specifically for Chemo.
Just Chemo.
For all of the discussions that we've had, could you explain Cavendish step by step? Could you?
Well, this was another unnecessary mute. David has a point. This is not a one-on-one versus me, and this should be allowed for every flat earther to have an opportunity to bring up different points. Okay, Now, obviously, David's making a point, and obviously he feels he has to shout because he's not being addressed, and he feels like the focus is not being directed in the right way. So, Curved, I mean, that is very uncalled for, simply because, he has a point to make, and that's why he's here and why we're here. Okay? Let's get David back.
I'd like to directly piggyback. I want to piggyback David's point, Kimo.
Exactly. So let's get David back into the
you as well.
Oh, he's back already. Good. Go ahead. Go for it. Yeah.
Well, cue me up. Does David gonna go first or Curve, or cue me up? Let me know when you want me to piggyback.
All yours. Oh, here he is.
I think
all right, so
this might be like free energy. We can't talk about it. I'm sorry, guys. Y'all have to figure it out yourself.
Free energy.
On and on. Let's see.
Right. So David's bringing up like the barometers, whatever they're testing the pressure. We're all talking about Cavendish, mass, influencing mass, right? Why do we even need, with the instruments and stuff we have, we should just have water in a fish tank and your little pressure sensors or movement. Like water in a fish tank should show you mass attracting mass, period. Right? Like if we can sense pressure everywhere and see fluid dynamics and stuff moving and streaky water, if mass attracted mass, wouldn't a fish tank constantly be stirring itself?
Why?
And why don't we
Oh
just
my
demonstrate
God,
that?
man! Wait, what did?
Oh, you can't handle a new thought? Can you not handle a new thought? You gotta neg me off the gate?
Actually, why? I'm saying elaborate.
Not you, I'm sorry. The other guy who negged me. Like, well, the fish tank walls would be stirring the water. Wouldn't it, guys? What do y'all think? Wouldn't it?
Why?
Because it's the mass is attracting mass.
Holy shit, dude!
Once some of the water moves, so you can never have perfectly still water.
You don't really understand tides or anything.
No, please don't understand me. I'm asking questions. Please don't do this.
You're dumb as shit.
I don't have time for that. I don't ain't got time for that.
You don't have
You guys ain't saying nothing. Y'all know that, right? So, Kimo, you feel me, right? If Cavendish, then they're claiming anything is never still, nothing. So just demonstrate that, guys.
Demonstrate what? Demonstrate what?
What the fuck is he talking about?
I don't know, man. He's
still liquid or gas, perfectly in a container.
In his mind.
Yeah.
I'm sure
in his mind, gravity somehow.
What?
In your mind, the gravity should steer the water. I don't know why.
Can you move stuff sideways or not? No.
What?
You can't. Only
This
down.
is
You can't move it a little bit.
ridiculous amount
Can't you put a
of misunderstanding.
Can't you put a scale on different angles and put weights and watch the scale be changed because of mass? You can do this. So a fish tank should stir the water. Thank you. You have to say it does. You have
You're
to
not
say
even
it does.
wrong, bro. You're not even wrong.
That's right. That's right.
You've got like a couple before you get to just dumb.
No. I'm backing up everybody's claim.
Why would a fish tank stir the water?
Because a little bit of the water couldn't settle equilibrium down because it has influence from the sides, right? And so the little parts that are right on the edges are going to have more influence than the parts that are in the middle, right? And so that can never be equilibrium. It has to have a cycle.
How much of a gravitational force do you think the sides of an aquarium exert on the water in the amount?
Non-zero makes your question
just
relevant.
Tremendous, yeah.
Any makes my point relevant. If there's any value, which there is, it makes my point relevant.
No.
You guys are all waking up now.
No,
You're
it's
all
not
waking up
enough.
now. Thank you. Kimo, you see? There's not enough. So if it's gas, what about gas?
You know what? I find myself.
Would it be enough? What if it wasn't a fish tank? What if what if it was the walls of a building? Would it be enough then?
Yes, sure. The sofa, Don, the sofa in my living room exerts a gravitational force on me, pulling me to it. It does.
Exactly.
It's just not very big. It's really, really tiny.
But when you're talking about sensitive pressures and these sensitive instruments that you have, right, and get light gases and liquids, there some movement equals not still, and you should be able to show the fluid dynamically moving in the fish tank or the fish wall tank or whatever you want to put it.
Say Don, you know the LIGO experiment?
I've heard of it only.
Right, that's where they measured the gravitational effect of two massive black holes light years away. Do you know how much that effect was when it got here?
You don't need.
It was.
You don't have to use lasers to demonstrate what I'm talking about.
It was a fraction. It was a fraction of the diameter of a proton, and that was for two massive black holes. The fuck do you think a sofa is going to do?
Far away.
Yes.
Very far
yes.
away. It's irrelevant, Brenda. You don't want to address the point. You're admitting that on some level, the water is going to be attracted to the sides of the container. You're agreeing with me on that.
A billion of the diameter of...
You're trying to unmeasuredly hand wave it.
Unmeasuredly? What the fuck?
By saying it's a little bit.
Well, yes, because it would be probably not measurable. However, surveyors have measured the lateral movement or traction from a mountain on their equipment.
But my
they
point
have.
Is you don't have the edges of water moving. You don't have the very, very edges near the container moving at a different rate than other portions.
Right.
And then have the middle portion. You don't have the middle portion ever being still if you look in fluid dynamics. It's never going to be, you're going to have a
fine, who cares?
spiral drag and all this bullshit going
So what do you think? Okay, so let's grant you. So what?
Like, so we're agreeing then.
Well, let's grant that everything is always in a very tiny way moving. Okay.
All right, so now what type of gauge or dies or setup do we need to have to witness the fish tank cavendish?
Thermometer.
Or fish tank mass to mass, or whatever you guys want to keep saying, mass.
Well, it would probably be similar to the one that was set up recently with the millimeter gold or whatever they had. It would be similar to that. It'd have to be very, very sensitive equipment.
Gold foil. See, Kimo, so wouldn't this be cool, Kimo, without like not even vacuum? Like we could just use this. I don't think they have it, Kimo. I don't think they have it. That's why I'm willing to call.
Well, the recent.
You see how they jumped down my throat.
Well, Don, the recent experiment with the gold, I don't know, they're what, 9 millimeters in diameter or whatever they were. That was done in a vacuum.
Oh, even better.
Yeah, so we've met all your requirements.
So it's pretty interesting though that like Brenda gave me the respect to think about what actually exists out there to talk about the phenomenon I'm talking about. After a little bit, you caught me a little bit on the magnitude, Brenda, but everybody else want to just clown on this shit.
Well,
crazy.
It's a general tactic that I have, what I use with creationists and other conspiracy theorists. I simply grant them their hypothesis and then show how their beliefs are still wackadoodle. So
yeah, sure.
Yeah, and so the fact that the walls of an aquarium may exert a small amount of gravitational force on individual molecules of water inside the aquarium, it's just, it might move them a billionth of a nanometer or something like that. But who cares? The problem is one of scale. You're never going to measure that. You're never going to see it, and you can treat it as if it's stationary. You can do that because.
Okay, what if we took an anvil though? What if we now we introduce an anvil to one of the sides of the aquarium?
Well, supposedly there's that YouTube video where they put a weight underneath a scale and they measure the gravitational force. There's some people who they're skeptical about that. They don't think that was. They're skeptical about that experiment.
The
People may affect
legitimacy,
it.
basically, or the control.
But let's say it's true that you can just move a lead weight underneath a weight that's dangling from a very sensitive scale, and you can measure the gravitational force.
Right.
Okay.
Right. But now if we do it from all sides, we can rule out certain, if we want to say it's some sort of ley line thing, we can rule out certain orientations.
I don't know what ley lines are.
I just want to say magnetic lines, but people are going to kill me if I say that word, so I can't say that word, like EM or whatever. But either way, if we do it from sides, we can then, rule out that if they want to use it as a hypothesis that it's orientation.
So
it would have a all-around orientation.
Right. So Don, what are you trying to go with all this? What difference does any of this make?
Don, are you preparing?
I don't know. I'm skeptical.
Don, are you preparing the next goalpost move? After we have a vacuum, you will need a fish tank.
To be honest, I thought I was going to bring the goalpost closer.
You think? Let me tell you. You draw on a paper all the forces that you think are in play, and let's see if they should move the water. Okay.
Yep.
Yeah, there's going to be electrostatic. There's going to be electrostatic forces. There are going to be magnetic forces. They're going to be minuscule and probably not make differences that you could even measure, much less observe. Very
Absolutely.
likely.
And Brenda, I also was trying to just get in a quick ignorance test for to see how many dumbass Globers was going to think how idiotic it was at first.
It is, because Don, I don't see any reason the water will move. So please draw it on paper and try to explain to us why the water will move.
Yeah, I don't think the water. I think that you might get a molecule of H2O being shifted right a millionth of a proton's diameter by the walls of the aquarium that it's in. You're not going to get a whirlpool. You're not going to get the water turning. Nope.
You'll have a conical resistance, Chike, with a standard no room container. You'll end up having a conical pattern.
What is that?
And that I think would anticipate movement. Thank you. Because of you don't have straight parallel gravitational.
I don't know what conical.
You don't have a parallel center of gravity throughout the whole unit.
I don't know what any of these. What on earth are you talking about?
Center of gravity.
The center of gravity.
Trying to wits it. He's simply trying to wits it. That's all.
Bullshit. I'm trying to communicate with you guys. Honestly.
No.
Bullshit. I was asked a question that's my honest answer.
Well,
Chike asked me from the force vectors. Chike asked me about force vectors, and I'm trying to tell him, okay, well, I don't have a pen and paper in my hand. I can't draw the little shit. Chike, I see a certain pattern that would not have parallel center of gravity throughout all the masses. And therefore, there would be shifting because of not solid resistance. The fluid is able to move, so it would move. That's what I see, Chike. Could be stupid, but that's what I'm seeing, Chike.
Well, Don, if you have a glass of water and it's been sitting there all day and it's perfectly still, the molecules in the water are still moving, and fairly quickly too. It's just that the overall average is such that it looks to us to be pretty still, but they're moving. All the molecules in the table that your computer is sitting on, they're moving too. They're vibrating.
Supposedly.
Yeah, no, they are. So what? So what am I supposed to take from all this? Who cares?
Well, do you ever have heard of an experiment that witnesses sound like I got to look into this gold leaf thing you're talking about or whatever?
I don't know. What's it?
Maybe we could all look deeper. Like
what's it as a clown? It's more of a performance, I think.
Please don't make me be a performance. I'm like, please don't make that. Anything for performance, it's just to be nice and share energy, guys. If I'm asking a question, I want the answers, and I appreciate them. Thank you.
Yeah, I can't tell if Whitsitt is for real or if this is just a scam that he's doing. Probably the latter, if he's hooked up with Nathan Thompson. They're both scam artists.
Well, not anymore.
Yeah.
At least one of them are.
Yeah, that's true. That's true.
So when the science fails, the ad homs replace.
Well, Kimo, it's often based on prior history. People have a history with you and with Don, and they got baggage. And there's baggage, and that has a factor that affects things.
Well, Kimo, if you could come up with a cogent argument, just once, without.
That's not what we do. What we do is expose the globe lie. We don't have to make any arguments.
I can be doing something. I could be watching Doctor Who right now. I should go.
So proving the flat Earth means proving that the globe is false. Gotcha. You can't prove the flat Earth, so you prove the globe.
Well, they've always known the Earth was flat, and then obviously
no proof. Then how about some proof, please?
Flat Earth is not a claim.
Yes, it is. Prove it.
Group of people came along and said, "No.
Well, if it wasn't a claim, we would know the Earth is round without going to space and doing.
Oh, we would. Yes, you can do it in 4 days. The perfect time to do it. No, Bon Jovi. 4 days.
See, you have to prove the Earth is round by.
Yeah, in 4 days. We'll do the EARTH experiment in 4 days.
We agree.
You can do it in your wheelchair from Bahamas.
Why are you always balling on my wheelchair, man?
Jovi, and you also have a proof to do. You have to prove that you're not a fucking troll.
What about you? You could be a globe troll, pretending the Earth is a ball, with no evidence.
Well, to be fair, I'm not a flat Earth troll. Like, I am a flat earther, but I am a troll, just in general.
Oh, we have proof, good Kimo. It's called the EARTH experiment, and I invite you to do it in 4 days to prove that the Earth is round.
Eratosthenes? What's the results of Eratosthenes?
Oh, you tell me. You do the experiment in 4 days, and you tell me. Thank you.
It's already been done.
Well, no shit. That's called verified. That's what people who study science do. Is when you're undergraduate, you start verifying these experiments. You do them yourselves to prove that they are true.
Yeah. So all we need is the radius.
No. You calculate the radius from the shadow.
Excellent, fantastic. So we now have a radius. Yeah, that's where we get the R value from. Yeah.
R value. You mean the amount of insulation in your ceiling?
No, the radius.
Oh, the radius. Why don't you just say radius? Nobody says R value except if they're talking about insulation in your roof.
Well, we have the radius then, right?
Well, you can calculate that by the EARTH experiment.
Exactly.
Get the radius from.
So do it.
Why? It's been done already.
Well, yeah, but you seem to think that it hasn't been done because you think the Earth is flat.
No, I'm not doubting that. Someone called Eratosthenes have done it. You've repeated it.
Is he doubting the Earth is flat now?
Are you happy?
So you're welcome to Globe Earth. Thank you.
Okay, so you're happy with the number.
Happy. Welcome to Globe Earth.
Okay, thank you. Are you happy with the?
On that?
Are you happy with the radius 39? 3959? Yeah.
Welcome to Globe Earth.
So you're happy with that radius, yes? Just sticking to it.
Yeah, but you prove it yourself in 4 days from now.
Oh, for goodness sakes! Why are you arguing? You're happy with the number. That's the results. Yeah.
I'm not arguing. I'm saying you don't have to be happy with it. You don't have to accept it as fact. You can determine it. You can calculate it yourself.
And I'm sure I would get using your method 3959. Yes.
Exactly. Welcome to Globe Earth. Thank you.
Okay. No one's arguing with that. Again. So now.
No one's arguing with that. Good. Then welcome. What are we arguing about then?
So there is no argument. What we're going to do now next.
Okay. Good. Welcome to Globe Earth.
I thank you again for the second, third, fourth, fifth time. So now we have the radius, and we can start using geometry to work out how far the horizon should be for an observer at, say, 1 foot or 6 foot or whatever feet, right?
That's correct. It's called the geometric horizon, and it exists.
Wonderful. So what we can do...
You want to see what I did last night pertaining to this?
Whoa. We don't want to see what you do at night.
Whoever said that's a good comeback.
This is what I did last night, and it was prepped by
Oh, that's a nice drawing.
QE. QE's claim, and I thought that was strange, so I looked into it. Come to find out, it's so weird that he posts the wrong information in order to get a lie across as fact.
What?
It was so
No
surprising.
way. So surprising. I mean, QE lies? You didn't cherry pick. You
It's
just
crazy that he lied the distances to bolster his lie. That's crazy.
Wow.
Fake image.
You know what? I'm starting to doubt this QE guy.
Look, you
Yeah,
ad homs.
I have doubts now.
No, Kimo, I said it was surprising. I was complimenting him.
Yeah, that's all you have is ad homs.
No, actually no, because QE is a complete and total dummy. He knows nothing.
Exactly.
He cherry picks.
All you
He
have
cherry
is
picks. He has no study of science. He has no idea what the hell he's talking about.
Yeah.
Yeah, but there you go, Kimo. So I found a claim that someone had made that goes against how I know the world to be, and I investigated it myself. Find out that he was 33 miles off, and I provided all the proofs for it. Would you agree that QE is blatantly lying?
No, what is he trying to measure the radius?
No. We're talking about how far you should be able to see something.
Alright, but does the calculations come to 3959?
Oh, I'm sorry. You had moved on from the radius. We were done with that. So what I brought
No, whatever
presented-
QE. So QE got it wrong, and it doesn't add up to 3959. Is what you're saying?
if that's what you're taking
not
from
how
this,
we
then
measure
you
I
have
don't
no
know.
idea
I'm
what's
asking
going
you.
on.
Does the result add up to 3959 at the end?
I don't think that's
It's
what we're
not
talking
how we
about.
measure.
Doesn't
Sorry,
matter who
we've already
measures
moved on to
what. The idea is the end result should be 3959.
Based
it
on
shouldn't. He's
35,
looking to come out.
based on 3959,
Mm-hmm.
we should be able to see the mountain that's shown in this picture from a great distance.
Okay.
QE's claim is that we shouldn't be able to see it, but he used falsified information in coming to that conclusion.
Okay, so your conclusion comes to 3959. That's all I need to know.
Using 3959, we should expect to be able to see that mountain peak. In the picture, it is verified that we do.
Right, so if the Earth is 3959 and you're 1 foot, you know where the horizon should be. 1.22 miles away.
That's where it is.
That means the Earth...
Assuming no atmosphere, correct.
Yeah, assuming no atmosphere.
No, the physical Earth will drop away.
That's correct.
Right.
Assuming no atmosphere.
What? So if
Yeah,
there's
you're not gonna-
atmosphere, the physical Earth doesn't drop away.
Chemo.
Oh.
What you're saying is that,
Because of
what you're saying is that
refraction, we
we
know
would
about
see it. You said at 1 foot we would see the horizon.
But you're saying if
1.22
there's
miles
still
away.
atmosphere,
No, Chemo. I didn't
the
interrupt you. Shut
physical
the fuck up.
Earth
Shut the
does
fuck up. I didn't
not
interrupt
drop
you, Chemo.
away. Is that what you're saying?
Chemo, you said what we can see at 1 foot is 1.22 miles. Yes, we can see that with no atmosphere. With an atmosphere, it's
I
going to
didn't
fluctuate.
say that. I said the physical horizon should be at
That's correct.
1.22
It is.
miles away.
And it is.
The geometric horizon. Let's make
That's
that
correct.
distinction.
And it's there. The geometric horizon is right there. You're
Yeah.
correct.
So whether the atmosphere is there or not, that geometric horizon is still there.
That's correct.
Oh yeah, that's fine. No problem.
Right. So the physical Earth from 1.22 miles should start to drop away.
If we had no atmosphere.
No, I said the physical Earth, not the atmosphere. The actual physical Earth should drop away.
The
at
atmosphere is part of the physical Earth.
Oh my goodness. So you walk on the atmosphere, do you?
You don't think the atmosphere is physical? You don't think the
Oh,
atmosphere
you
is
can
physical?
walk on the atmosphere now, can you?
Do you think the atmosphere isn't physical?
I'm asking, can you walk on it?
Is the atmosphere
Not
physical?
everything that's physical you can walk on.
You can walk on the atmosphere now, yeah?
No,
So
not
the
everything that's
atmosphere isn't
physical,
physical.
you can walk on.
There's no such thing as wind. There's no such thing as wind. You can walk out on the wing of it. How do airplanes fly
Can't
if
hear
if the air isn't physical?
Say surface of the water, Chemo.
See,
Surface of the water.
all I'm asking is from 1.22 miles away, the physical Earth should drop away. Regardless
Correct.
of
There's no
atmosphere or
atmosphere.
not. You can have all the atmosphere in the world, the Earth itself should drop away at 1.2 miles away.
And it does.
What's so hard
Well,
to
technically, it's
understand
going to
that?
be dropping the entire time. Let's be honest.
That's correct, but yeah.
And, okay, so you're good, you agree. So that means The black swan shows the horizon.
No, incorrect. Because of refraction, and we know about refraction.
Yeah, but the
That's called
Earth.
atmospheric.
Yeah, I wish we could see the black swan with the atmosphere removed. Can you do that,
Yeah.
Kimo? Can you give us that
Yeah,
experiment?
why don't you
Remove
give us
the
that
atmosphere?
experiment where you move the atmosphere and let's show us a black swan?
Right.
I'm hearing doubles.
Yeah, because we're saying the same thing because you're doubly stupid.
Okay. So, if the Earth is dropping away at 1.22 miles, okay, but we see the horizon dropping away at
called
10
atmosphere.
miles.
Yeah,
So
refraction. Thank you. We know about
between the
refraction.
1 foot observer and the 10-mile horizon,
I thought you can use optical things to prove stuff.
there is no physical drop for
There is
10
physical
miles.
drop. It's
So
being
we have
refracted.
a straight line of sight for 10 miles of no curvature in between those 2 points.
Oh, yeah,
right.
because of
You
refraction.
added a variable called atmosphere when between talking about the geometric horizon and now we're talking about the black swan. You added an atmosphere.
No, the horizon where the Earth drops.
All right, so we were talking about geometric horizon earlier, and that's fine. We all agreed to that. There was no problem. So now when you talk about the black swan, is there an atmosphere?
Is that there's atmosphere everywhere.
Right, so you've added the atmosphere. So what's the problem?
Is that the drop for the Earth is 10 plus miles away.
Yeah, because the atmosphere. We know that.
No, the Earth
No.
didn't change, Kimo. The Earth didn't change at all. How we are viewing what we're seeing
So
changed
one
because the
day,
atmosphere was added.
on one day, the drop was 1.22 miles away, and the Earth was going down from that point. And then on another day, the Earth went down from 10 miles away.
Yeah. Well, you think the Earth's diameter changed in a day?
Exactly, broken geometry.
No,
Welcome to flat.
totally
Finally,
incorrect.
you're getting it.
No.
Welcome to flat
totally
Earth.
incorrect. You're freaking totally incorrect.
What are you
happened
talking
is
about?
the
You've just
refraction
said, is the Earth changing size? That means you understand the Earth cannot change size. There can only be one
Correct.
horizon, but what we've got is a horizon
there
at
is.
1 mile
Actually,
away,
no.
and then another
there's
one.
one horizon, but what your problem is what you're seeing is the
You've just
apparent
said it
horizon.
anyway.
But then you're missing the necessary antecedent to the visual horizon, which is the geometric horizon.
You know what's going on. You've just said it. The Earth is not
Oh, yeah,
changing size.
the geometric horizon is there, but the atmosphere is being refracted into the apparent horizon. So you have the necessary antecedent of the geometric horizon being refracted into the apparent horizon.
Okay, so look. At 1.22 miles,
No,
the
stop.
Earth
No, is there an
starts
atmosphere?
to drop away.
Is there an
The
atmosphere?
physical Earth is dropping away at 1.22 miles.
Is there an atmosphere?
What's wrong, Rakia? Why is the mods terrible? What's the problem? Who's bothering?
Is there an
Rakia?
atmosphere or not?
Bothering Rakia.
Rocky doesn't like me.
Rocky is commenting how terrible the voice chat is right now, thanks to you, Chemo.
Why? What's the problem? You're saying the mods are terrible.
Well, he has a hard on for me, but that's an issue.
What's the issue here?
He has a hard on. That's all. It's a chubby every time I talk.
Oh, he's not even in the VC. But anyway, you've got the horizon at 1.22 miles. That's where the Earth...
Wait a minute, you got the geometric horizon 1.22 miles, yes.
Yeah, and the physical Earth starts to drop away beyond that point.
Actually, it drops the entire time, but that's another issue.
Well, you've got a straight line of sight for up to 1. If you're 1 foot, you can see the horizon at 1.22 miles away. So you don't
correct.
see the curvature between that point until after the Earth
Actually,
drops
there
away.
is curvature, but okay, I'll go.
Yeah,
go
but you
slide on
don't
it.
see any obstruction between
correct.
you 1 foot and the 1.22 miles. There's no
Yeah,
obstruction.
okay. Yeah, what's the problem?
So now,
If there was no atmosphere.
So what we've got with the 1 foot
If there was no atmosphere.
Yeah, I hear you.
You always leave off the if there was no atmosphere part.
No, yeah, but I hear what you're saying. But the drop.
No, you don't hear what I said. Because if there was no atmosphere, what you just said is true. However, there is an atmosphere.
It's
and
really not
therefore
getting
it
it,
is
are
often
you?
refracted.
This is not
What's that?
sinking in. It's not sinking in, is it? So think about
No,
what
it's
you're
not
saying
sinking in.
here.
Definitely, you're right. It's not sinking in for you because you keep on leaving out if there was no atmosphere.
Let's think about what you're saying. We've got the horizon 10 miles away. And
Because it's
between...
been refracted away from the
Okay, fine. So you're saying between you, the observer, and 10 miles away, you're saying the Earth between that point is dropping away. And the only reason why you can't see it
It's
is
being
because
refracted.
of refraction.
Yes, what you're seeing is being refracted, yes.
Okay.
But you only pick the really refractive days
How on
to show.
earth
You
would
don't
that
pick the
even
normal
work?
days. Oh, yeah, of course you don't, because you do know how it works, but you're just kind of stuck, because you can't accept the fact that it's being refracted, and we know about it.
Well, explain. You've got the physical Earth dropping away at 1.22
refraction?
miles.
Refraction. You know about refraction.
Uh-huh.
You always use refraction incorrectly when you want to use it, and now you're ignoring it when it actually is refraction. Amazing.
But in the Black Swan, the drop is 10 miles away.
No, the drop is still the same place. You just have a highly refractive day.
So you're saying
water.
between you and the 10-mile horizon, you just don't see the Earth drop.
I mean, you see the Earth drop, but it's being refracted.
What, back?
Don't you understand?
10 miles.
What?
Away 10 miles.
Okay, so it's being refracted.
That's what I'm asking you. It's bent backwards 10 miles away.
Bent downwards, yes.
Yeah, down and away.
Because of the temperature difference.
Yeah, so the physical one is 1 mile away, and the one we see is 10 miles away. You're saying it's being refracted further back.
Yes, correct. That's how refraction works.
Fair enough.
When light bends down, distant objects are loomed up.
That's where you guys have got huge problem. Between the observer and the 10-mile horizon, you think the Earth is curving down away. So you're looking at the water, that's 10 miles of water, and you're saying at 1.2 miles away, the Earth is curving down.
It's always curving down.
It's always curving down, Kimo.
Yeah.
It's curving down a millimeter away from your point.
But the drop is 10 miles away.
No, there's no...
Nothing will disappear until 10 miles away. So no ship, no sun, which usually drops away at 1 mile, will not disappear until 10 miles away.
Your dead swan observation was done on a day when the refractive index was about 1. Okay.
So let's try and go through this again. So today, the ship will disappear at 1.2 miles away today. Tomorrow, it will disappear at 5 miles. And then on the day 3, it disappears bottom first 10 miles away.
Actually came over according to the guy that made the dead swan video.
You guys are proper like...
It looks just exactly like this picture you're looking at that I just posted.
Right, so let's say this horizon. Let's look at the horizon that you're showing here. So if the boat goes,
the word most, right?
If a boat goes beyond this horizon we see in the thumbnail, that's 1 mile away. Then tomorrow the boat will disappear over a horizon that's 5 miles away, and then the next day
you don't know that.
The horizon will be 10 miles away.
You can't say that. What the guy that made the video said was most days this is what you see there in the thumbnail.
So a boat will disappear bottom first over that horizon, yes?
Mm-hmm.
Right.
And you haven't yet explained to me how a horizon like that could ever be in front of any object on a flat Earth.
So everything will disappear beyond that horizon and go down below the horizon, right?
Yeah, just like that oil rig on the left. Yeah.
Yeah. But tomorrow, things will disappear at 10 miles away. How do you explain that?
Not necessarily. Tomorrow may look just exactly like this, just like the guy that lives there says it does.
Yeah, but that horizon will be behind the platforms tomorrow.
No, that's not what he says, Kimo.
So how do you explain the horizon being behind it 10 miles away? So that now means when we look,
extremely high refraction,
we will see a boat go past the platforms and then beyond the horizon. How do you explain that?
On a day when you've got extremely high refraction, yeah, you can see that.
Yeah,
high refraction essentially flattens out the curve.
Yeah,
That's
so refraction.
What it does.
So you're saying that this horizon we're looking at now, we will see objects go behind it 10 miles away.
No, you can't see. You're not going to see on this horizon.
So how far is that horizon there? Is that 10 miles or 1 mile?
Would you like to pick a number in the middle?
You don't know,
Maybe
do
3
you?
miles. I don't.
It doesn't. You even if you ask me
I
the
don't know
height
for
of the
sure.
observer, it still
I
doesn't
can
matter.
tell you why I don't. I'll tell you why I don't know for sure, because I don't know for sure what his camera height is. I
Well,
think he was at around 3 feet.
What does
so
it
If
matter?
he
What
is, then that horizon is a couple of miles away.
what does it matter? The height of the observer.
What does it matter? You've outdone yourself this time, Chemo.
Well, you can't explain why you need the height. Why
observer
would you
makes
need
a
the
big
height?
difference.
What for?
Basic
You don't-
geometry,
you
the height
are-
makes a big difference.
Explain why you need the height.
Seriously going to tell us. You're not seriously going to tell us that you can't understand why you need the height.
I want you to explain why you think you need the
why
height.
that would change. Why that would change the position of the horizon.
Why do you think you need the
can't
height of
understand
the
how-
individual? What difference does that make?
Because that definitely changes the
The
position
height
of
of the
horizon.
observer determines what point you're going to be able to see on the horizon.
No, it
Chemo.
doesn't. That's the point.
Yes, it does. Sorry. You don't know what you're talking about.
See, that's what the black swan shows, that the
Simply
height
no,
of the
no, the black
observer is irrelevant. It doesn't
No,
matter
incorrect.
the height.
Incorrect. If you had actually, if you gone on the Black Swan day, if you'd gone higher, you would have seen less, because the refraction is strongest closest to the water.
Get out.
But that's another issue.
Get out of the refracted zone and things will
Yeah.
start to disappear.
Yeah, things
So-
start to act normally again.
So the old argument was the higher you go, the more you see. But because
That's
of
correct.
the because of the black swan,
No,
you don't
no,
need
no,
to go
no,
higher
no, no,
anymore.
no, no. Black Swan. We know about refraction, and you're in a highly refracted environment over water. It's amazing how flirts always use the over water proofs. Hey, we see too far over water. Do you have any proof that's not over water
So
on a highly refracted day?
So the height is not important because
The height
the-
is important, actually. No, incorrect. Totally incorrect.
Well,
You can always see further from a tower than you can from the ground.
Do you have any kind of pole?
Well, the reason why it's not important is because what blue is showing as the obstruction, okay, to see the bottom of those platforms, all we have to do is just wait for the atmosphere to change, the weather to change, and then we will see. We don't have to go higher. We can just wait in the same height.
Again, or you could go
saying
higher.
that you cannot see further from a higher elevation.
No, you don't need to. You just need to wait
Yes,
for
you
the
do.
weather to change.
Oh, wait for the weather
If
to
something
change.
is obstructed, we can bring it back by having the weather change.
Some days.
Yeah.
Yes.
You
on
don't
rare
have to go
occasions.
higher. Yeah, that's right. You don't have
Well,
to go
you
higher.
normally you do. Yeah, normally you do. It's a lot faster to go higher than it is to wait for the weather to change to the perfect day where you see the black swan.
But if you're saying
long do
if
you
you're
have-
saying the height
you know-
matters, like you're 1 foot, then you should only see your horizon at 1.22 miles away.
Yeah, except that you keep leaving out the same words without an atmosphere.
So what swan shows, you can see as far as
The black
possible.
swan shows that you're in a highly refractive day. We know about refraction, Kimo. Stop it.
Yeah, so you can see as
You're
far
being
as
disingenuous.
you can see as far as you like, depending on the
no,
weather.
not as far as you like.
Of course
So
you
how
can.
come on a flat Earth you should be able to
Really?
see? You should be able to see forever on a flat Earth. How come you can't?
Well, you got your
How long
perspective.
do
You got
how
your
long
limit
do you have to
perspective.
wait, Kimo? How long do you have to wait to see 100 miles away?
If we're underwater, we
Depends
should be
where
able
you
to
are,
see
doesn't it?
thousands of miles underwater.
There, with the platforms on.
It depends where you are.
We don't see
Yeah,
far
where
enough to
you
be on a
are.
flat Earth.
That's
I always
the
love this.
same
I
point.
always love this. We see too far argument. Then we don't see far enough to be on a flat Earth.
Yeah, but on a flat
Right.
Earth, dude, there's still atmosphere. There's still dust and.
Yeah, okay, but you could see a lot further. You should be able to
Called
see like the
turbidity.
Rocky Mountains from Kansas City.
Atmospheric
How come you're being
turbidity.
disingenuous?
What? I'm not being disingenuous.
Yeah, we have shots. We have shots in our atmosphere.
Hey,
that have
Wama,
been
what's
taken
going on?
From okay, as you talk over
Hey,
me.
Kimo,
As
how are
we
you,
do
buddy?
have
Who's this?
shots
Who's talking now?
We're just showing
my
these
goodness,
guys
we
that
do
the
have
black
shots
swan.
from 200 miles away. Those do exist because they have altitude in order to see those observations.
Because the resolution
Correct,
of
but
the
on a flat
image
Earth, you
is
should be able to see the mountains from like Kansas City or something. You should be able to see them
200 miles should be the norm from
300,
ground
400,
level
500
on flat
miles. You
Earth.
should be able to see them like up from the East Coast.
No. The atmosphere prevents you from seeing as far as you would like to.
Oh, but the atmosphere
We already
doesn't
have
cause rays,
observations
doesn't cause
200
refraction,
miles
though.
away.
Okay,
Those do
gotcha.
exist because of altitude.
Well, I thought the atmosphere is perfectly clear. It doesn't have any effect on anything.
No, at the
Except it-
horizon, you get the most distorted effects. So things
okay.
can appear to disappear bottom first. Not
No,
really
that's
happen.
incorrect. No, that's no. The bottom first thing is you're totally wrong on that.
That's just
The bottom first thing is another proof of the globe.
It's just
but that's another issue.
an illusion.
So how does it work with the sun? How does the sun go down at 30 arc minutes big because of the?
That is due to atmospheric lensing.
No, incorrect.
Well, we have an experiment to back it up. So
experiment that
you don't have an experiment. You have a hypothesis, and you have poetry.
You have the experiment that you assume the atmosphere behaves like without any justification whatsoever.
Remember, doofus, if a hypothesis agrees with experiment, you're correct.
No, you have to justify why you think the atmosphere acts like a lens.
You got Rob Scavis experiment.
Doofus, does the experiment agree with hypothesis?
Your experiment agrees that you used a lens. You didn't experiment on the atmosphere itself.
Yeah, but did it agree with hypothesis?
Your hypothesis was flawed because the atmosphere is not a lens.
I know, but I didn't ask that. I asked you about my hypothesis. Did my experiment agree with hypothesis?
With a flawed hypothesis? Sure, it agreed with it.
It agreed. So, if we have an experiment and it agrees with hypothesis, doofus, then that is correct.
Okay, it doesn't have anything to do with our atmosphere now, does it?
Well, do you have a hypothesis that agrees with experiment?
I do.
Where?
I can show you all about how light bends down in a density gradient with the highest density below.
Yeah, I'm sure you can, but where's the experiment?
Show the experiment. Oh, now we got someone who's really the disingenuous one.
You could wait for me to go get it, you silly bitch.
Well, we're waiting.
So,
but you probably won't come back.
Probably.
Whammer, you seem to be caught in a windstorm or something. Do you think maybe you could protect your mic a little better?
Oh, he sits like the mic police. Goodness sake.
You always have to obfuscate to my mic. Well done, nice try.
That's perfect.
Moving on.
Perfect. Well, till the end.
Yeah, so again, once again, the flat earthers are in pole position because we stick to the science. What you say, doofus? Where's your experiment?
With these three things that I just posted.
What you posted here? Okay, you've got light bending, green light bending in sugar, I take it. No sugar in the natural world, that's not an experiment. Your second one, you've got the geometrical physical horizon that doesn't change, doesn't move, so this is accepted. Yep, I accept this. Refraction, this is how refraction should work. You have a geometrical physical point that doesn't change, and the object beyond the geometrical physical horizon will refract over that doofus. Not the horizon move, the object beyond the horizon will move. So number 2 is fantastic for our claim. And number 3, what do we have here? What is this? Area, mirage, demo.
You have the curved surface curve less than the light is bending, then what you have is you see more of the curved surface.
In which one? In the third one?
In the second one.
Second one, you've got a fixed point, fixed horizon, which is what we expect. And we see the red, which is beyond the horizon, beyond. We can't see it. It's blocked physically. You understand? Physically blocked by a physical geometric point. And with a temperature change, we cause refraction, which is what we tell you, beyond the geometric. Now, what you need to show, doofus, is that yellow line behind the red.
Okay, I'm going to say this again because you didn't listen the last time I said it. If the curved surface is curving less than the radius of the bend of the light, you see more of the surface.
All right, but what we're looking for with the second gift is the yellow Not the red rising, but the yellow behind the red. Do you understand that yellow line, that yellow horizon line? You need to show that behind the red and not the red appearing over the yellow. Do you understand? Exactly. That's what the black swan is all about. The yellow is behind the green and red, which is impossible. How does that happen? And you're showing the red coming over the yellow, which is what we should expect.
I'm going to say this a third time because you weren't listening yet again.
Okay.
If the surface that the curved surface is having a less of a bend than the radius of the bend of the light, you see more of that surface.
Yeah, that's with a fixed point, yeah? Do you understand? So the horizon line there is...
If the surface, the curved surface itself has less of a radius of bend than the curve of the light, then you will see more of that surface. Let me go get the bearded devil ones.
No, you could get any ball and put the object on the ball, any size ball, and pour this liquid, whatever you do, and you would see the red, because that would loom up, refract up, yeah? But the horizon would always remain in its location, its position, forever. You would never have the horizon behind the red and the green, and have the red and the green stay still. But the black swan does that. The black swan puts the yellow horizon behind the red and the green. You understand? So it doesn't matter what size of the car. You can get a ball, you can use any basketball, you can use a beach ball. You can hide the object behind the curvature. Behind
Here
curve.
you go, by the way.
You're thinking about refraction again. Why don't you just totally ignore refraction?
No, we've got a video now showing refraction at work.
Yeah, okay. So what's the problem?
Is that the horizon
Holy
is
shit,
fixed.
have you not been listening?
Goodness sake.
Well, here you go.
The horizon is fixed, and the object is looming or refracting over that fixed horizon. That's what we expect on a ball, but in the black swan, we have the horizon behind the object.
Because of refraction, yes, we understand that.
Oh my goodness. If that's true, then show me the yellow line behind.
That's the way the horizon always look on a flat Earth, Kimo. It should always be behind those oil rigs. Always. Completely behind them.
Well, what Doofus has shown here is what we should expect.
It's in the chat right now.
No. Let's stick to your pipe, yellow pipe with the green and red plasticine. This is perfect for what we're trying to illustrate, which is when we talk about refraction, like things looming over the horizon. The horizon, just like this pipe, is in one fixed location. Doesn't move. Doesn't go back and forward and up and down. The curvature stays still.
Are you sure you're not a globe earther?
Yeah, of course we understand how this works, but what we have with the black swan is
the same thing.
No, we have the horizon.
The exact
moving.
same damn thing.
Yes, because the
exact goddamn thing. That's what you've got.
That's why you guys are stuffed. Really?
No,
because
exactly
unless you can explain
the same
how the
thing.
horizon is behind the object.
Because of refraction, just like over in the pipe.
We've
We
just
can see the light.
explained refraction. The object moves over a fixed position.
That's correct.
The horizon
It appears
that
to
you see
move,
in the
actually.
black swan on the particular day that you're cherry picking is land or water. It is water that you would normally not see. It is being loomed up.
Okay, so do that then. Show that you can put the horizon behind the object and then not the object in front of the horizon.
That's what the pipe does.
Yeah,
Thank
You're
you.
showing
done it yet.
Go on, Weimar, sorry.
Oh no, I was just saying they haven't done it yet. Show exactly what Kimo's asking.
That's what the pipe does.
No, you're showing the other way around. You're showing it refracting over the physical horizon. That's what's happening. That's what should happen on a ball, yeah. Not the horizon.
No, that's what happens. That's what's happening in the black swan.
Oh my gosh. The black swan is behind the plasticine in the black. How does that happen? Show that.
The looming that you see in that demonstration demonstrates that the water that you normally wouldn't see behind the horizon will loom up so you can see further.
What? Is something wrong with you? The
Yes.
horizon
Yes, there is
is
something wrong with
behind. The horizon is behind the red and the green plasticine. That's what we need to see. Behind it.
Yeah, and look at the demonstration itself. It's showing you things that you would normally not see.
But the horizon's still in
behind
front of the
horizon.
object.
The things that you're normally not able to see behind the horizon are being loomed up, so you can see further when looming occurs.
Yes, but listen. The horizon, doofus, is in front of the objects.
Yeah, that's what the bearded devil video is that you don't want to admit.
No, show me the horizon.
How do you see the horizon in front of it?
Doofus, show me the horizon behind the objects.
Yeah, and then you move the goalpost once we find that
That's
one,
the
right?
black swan, doofus. The horizon is behind the objects, not in
What about
front.
that bearded devil clip?
You see, you can't handle it, and that's what the black swan does. It destroys any idea
No, it
of
doesn't.
geometry.
It doesn't destroy shit.
So
The
what
doofus.
about
All it does is show that you do not understand diffraction.
Doofus,
That's
stick
what
to
it
the
does.
point.
No.
You don't understand
What about
fractions.
that bearded devil clip?
No, incorrect.
Doofus,
Oh,
stick
no,
to the
Babbitt's
point.
gonna
You
post the
showed,
stupid-
Doofus, you
the
showed
stupid
that pipe.
vertical column.
You showed the pipe. You said that's refraction. So
Yep.
now show the horizon behind
So
those objects.
How does the horizon? What do you think? What do you think the visible object is?
No,
If the pipe was
doofus.
big enough, there would be a
Doofus,
horizon
doofus,
behind it. If
doofus,
the pipe was
doofus.
big enough, there would be a horizon in front of it. But the pipe
Doofus.
isn't that big.
What you need to show is the horizon.
Listen to me, moron. If the pipe was
See,
big enough,
derailing
it would
here.
do exactly what you want.
Doofus, you're showing refraction, okay? But the horizon the whole time is in front of the object. In front. So you need to show the horizon behind the object like the black swan.
I'm going to mention this a fourth time. If
Okay.
the radius of the curved surface that you're bending the light around is less than the radius of the bend of the light, you will see more of that surface.
Okay. So can you show me then, like the black swan, the horizon in front of the object and behind the object? Is there any way you can
Take a look
replicate
at that
that?
bearded devil video then.
Bearded Devil's video is showing the horizon in front and behind of a curved surface, yeah? Is it curved? Is it a curved surface?
Is somebody literally sea lion in beach?
Is it a curved surface, doofus?
Yes.
It's a curved surface, yeah?
Yes.
What's the ratio? What's the rate of curvature?
I was looking that up while you interrupted me. Yes.
So this is a curved surface, not a flat floor or something, no? Just point me out where the horizon's in front and then behind. Give me the 2 timestamps and I'm looking at it right now. Doofus, you still here or
Sorry.
I think he's gone?
I knew.
I mean, this always happens. The ballers, again, they always
So
step...
if you look at around
Oh, he's
514,
here.
what you're looking at is the amount of looming is so strong that the horizon is nowhere near where it used to be.
Yeah, but what we're looking for is the black swan replication, with the horizon is in front of the object, and then the horizon is behind the object.
If the horizon can move, what do you think that means?
That's what I want you to show. Show that on a curved surface where the horizon is in front, obstruction, and then that obstruction is now behind the object.
So look at 514.
514. 5. That's all the way to the end. Okay, so what we're looking at here? We've got 510, 511, 512. Okay, so what? What we got here? What is this? What are we looking at here?
The horizon moved a great deal, didn't it?
But did it move behind the object? It's always in
Yes.
front. The horizon's always in front, doofus. All you're going to do is just take a screenshot, yeah, of when it's behind and when it's in front. And say, look, this is behind, this is in front. It's not that hard, because I can't see what you're talking about. Just show the horizon in front and the horizon behind the object. And this is because of the curvature, yeah? This is on a curved surface, like you said. It looks like it's flawed, though. It doesn't look like it's curved. You guys like to cut corners and do things, you know, sneakily. Is it a curved surface, doofus? Why do you have to lie to her? Why can't you just be honest and tell us, yes, we don't have what you need, we have what we think? I don't know why you put yourself through it, dude. Got Biodual now running around, buying Cavendish, buying Vacuum, wasting his life, wasting his money, wasting his time. And he could just be chilling out, relaxing on a flat earth, enjoying the time he's got. But he's there fussing about, oh, I'm going to prove Kimo and the flat earth is all wrong with this so-called experiment which he thinks he's going to do, which we already know doesn't exist, because if it did, it'd already be shown.
Yeah, that's all fine, Kimo, but you're showing us a curved surface and asking us if it's curved. Why is that?
Is it curved? There's a flaw in it. Just a flaw.
It's clearly curved, you know, it goes up above the observer, so
That looks
clearly
like
it's
distortion, heat distortion or something.
goes up above the observer, so clearly
Anyway,
it's curved.
fine. All we need is a screenshot of in front of the object and the horizon
Goes
behind.
up above the observer, Kimo, so clearly it's curved. If it isn't, then it must be loomed
Have
somehow,
you not
right?
been listening to like the last hour?
Oh no, there's something wrong with them.
Yeah, I don't have to listen to the last hour. It
You
debunks
just
itself.
haven't, so you're wrong, dude.
Is literally above the observer. You can tell because it's way more than a foot up those legs of that freaking platform. How did that happen?
We're dealing with, you know, spaghetti brains at this point, Kimo.
How did that happen? How did it get above the observer?
Trauma these guys are going
It's
through.
a very simple question. How does the flat earth somehow have water that is higher than the observer?
It's called waves.
Is it filmed from a submarine? It's a wave. How tall is
Talk
that
about
wave?
moving the goalposts, just full blown.
How is that water
bullshit.
above the observer? Come on.
You ever heard of water swells?
How is that
I mean,
water
this guy.
swelled without us knowing about the, 100-foot tsunami that went in there?
What?
Is the guy that filmed it dead?
That's the
Answer the water swell.
Is the guy that filmed it dead?
What?
Then
you
there was
answer
no water swell
No,
of
I don't know that guy.
several hundred
Are
feet.
you-
There
are
you
you
go.
talking
This is
about the-
fucking nonsense now.
Are you talking about the same water swell that we see in the
You
Black
want to
Swan,
see
rising the water level?
the earlier demonstration, okay, of the fucking horizon and light.
Water loses all its momentum usually when it gets to the beach. That's why their tsunamis don't happen. Turret working. Oh, another turret.
That's the thing, Kimo. There is no demonstration. They just shift away from it, shift around it. and
I do
simply-
appreciate
That's it. And then they'll ask
in
you,
I do
your
appreciate
you don't understand.
microphone, you insufferable.
Who? Who's he talking about now?
The guy who's blowing into their microphone.
Who's doing that? What's wrong with him?
I don't know.
Problem. Look, again, we only ask very simple things, and obviously, if we get the the evidence, then obviously we can move forward. But right now, we have wild claims, which need backing up. Now, the Cavendish, I support. This to me is a wonderful idea, and this should show that mass attracts mass with all variables. Now, a lot of flat earthers might not like this, but for me, this is what we need to prove that water, the tides and stuff with the moon, there's a connection, basically. Right now, we don't have any connection. We don't have anything. We have just poetry. And what good is poetry? It's not useful. Looking for. So yes, yeah, you have papers, you have peer-reviewed coming out of every orifice possible. But again, it's not backed up with an experiment, so you can't move forward.
Ever given us a straight answer about what pressure you'll accept? I mean, when I asked you that this morning, you said the pressure had to be 0, which is impossible when we're in the universe.
We already been through that. You're just being silly, Blue.
You haven't. What's your answer? What's your answer, Kimo?
I said I can't remember what Bio said. He said 10 to the minus either 4 or 6 or something like this.
10 to the minus anything. 10 Tor. You can't do 10 to the minus anything.
Well, it was something like this. I have to remember what he said.
We get our hands on here.
We'll have to get BioDual to confirm what was said. But don't worry about it. You've done your test, and the next generation are looking to prove.
Oh, I'm thinking about doing it in a vacuum now, just for the pleasure of shoving it up your ass.
Ah, I see now. Competition jealousy, because Bio will be the first person on Earth to, if this works, he'll be the first person ever to show mass attracted mass in a vacuum. You want to get busy, Blue, because he's already got the vacuum.
Full of shit, you know. You are so full of shit, Kim.
Wow, I'm saying, if you want to go ahead, Jovi.
No, don't worry. He's just being weirding me out.
Well, I'm just saying, Blue's thinking, goodness me, if Bio's on the case, I need to be doing this is my forte. So, Blue, you should have listened to us in the first place when we said follow the requirements, and once that's done, you've got your force. But right now, your experiment, we know what causes that. But you got pressure all over the place. Come on, pressure equals push, right? You
remove what causes it, Kimo. Quit playing that game. You're just full of shit. Everybody knows you're full of shit.
You remove that pressure, then there's no push. Yeah?
You are too stupid to show it. Do it yourself and prove that atmosphere is what's causing.
It's been done already. Why do I need to do it?
We're making the claim that atmosphere is what causes it. You say it will not work in a vacuum. You need to prove that.
I need to prove. We've got the paper, Blue.
Fuck the paper, Kimo. You won't accept the paper.
Paper says.
So you are.
Paper says it shows mass attracted mass in the vacuum. When we try to find the observation,
that cavendish actually does work in a vacuum. Is that what you? Is that what I'm hearing here? Okay with it now. Good.
You're not going to help yourself freaking out like this. Wait for BioDual.
You need to run a test.
You're not helping yourself, Blue.
We don't need to wait. What paper? Let me see the paper.
What you say, Chaiki?
We don't need to wait for a Bio.
I know, now you're nervous. I would be nervous too.
No, show us the paper.
But what happens if he fails? Then what are you going to do? You're going to accept no mass, yeah? No force.
If he fails.
You'll accept it, yeah?
But first he needs to show us that
he might be assassinated before, because they really don't want this to be done, you know. So you want to be careful, BioDual or Blue, if you do this kind of thing, because you're not going to show mass attracting mass. And I'm even worried for myself, because I keep pushing this, and they're probably listening. And if I keep asking this question, a question that they don't want, then maybe when I'm, out and about, I may have an accident or something to that effect. And because this is how serious this question is, right? All of you now will become no forcers, no globers, no spacers, none of that stuff. If BioDual fails show mass attracting mass, how are you gonna? What are you gonna do if he doesn't show it? You're gonna just say, "Oh, we got it wrong. He made a mistake. This is when you guys will absolutely spiral in amazing denial. If he fails.
Kimo, we don't have to, question that it will be shown. There is no doubt other than, what a freaking waste of money and time to prove your dumbass assertion.
I think he's wasting his time. Yeah, I mean, it's been done, but there was no movement. What's he going to do any different?
It has been shown to work, and there is no correlation with the amount of atmosphere in the formulation. So clearly,
it was shown that there was no movement.
Clearly, atmosphere has no effect, or it would be in the freaking formula.
It had no movement. Did you see movement? No.
Where is your citation for that, Kimo?
What?
Where is your citation?
Don't be dumb.
Done in a vacuum, there was no movement. Show us the citation right fucking now.
We've got the paper. How many times should I tell you this? We've got the paper. The paper says there was movement. We've got the observation, the photograph. No movement whatsoever.
You expect a fucking photograph to move, Kimo?
We'll show the observation. Show the observation then to the paper. You can't. Fail. That's why you're considering doing it. Bio says he's going to do it. Promised me last year. Gave me all the promises in the world. Oh, the big I am. Yeah, look at you, Kimo, you silly flat earther. I'm going to show you that mass attracts mass. Went to a college, went to university, denied. Said, you know what, I'm going to pay for it myself. I was like, whoa, you don't want to do that.
I heard this story. All I've heard it, the only person I've heard it from is you, Kimo.
Well, ask him next time he's here if he went to a college to find out if he can do it, because he said he's seen it in a college or university. That's his words or something to that effect.
Is it? Because you
Kimo, I've got to go, but here's your thing in the chat right now. You start at the timestamp that I have linked. I got to go read the story to my children, so I will be gone.
What is this?
Kimo, you misrepresent me a lot of fucking times, man.
What you want about? Who's that now?
It's your worst fucking nightmare, Kimo.
Oh, it's Bio. Oh, look, Blue wants to know what did we agree again on the vacuum? Remember?
Just cause and effect, no measurements.
No, but how much will the vacuum be?
Yeah, I don't think we talked about that. I think we just said.
You did. You said what? You gave me a number, and I was like, yes, I agree.
That's a good question. I don't remember. I won't lie about it. Misrepresent you. I just don't remember.
All right. So what would be?
The kind of vacuum pumps you can afford, you're not going to get down much below 20 torr. So that'll be about it.
It's going to be sufficient anyway. It's going to have no pressure in there. As long as there's no pressure in there, you're good to go.
There'll be a little pressure in there, Kimo.
How much pressure?
Pressure everywhere.
How much pressure? How much pressure?
I just told you, 20 torr.
How are you going to measure that? Exactly. Stop talking nonsense.
Idiot. The fucking pressure gauge, nitwit.
Oh, yeah. So let's see that there's pressure in there, and then we'll talk about it. But right now, Bio's going to remove the pressure, remove the cause. He's going to remove the cause.
You give us a number. What pressure?
Oh, my God.
What pressure are you requiring? Tell us now, Kimo.
Yeah, we already spoke about it. But Bio, did you forget? I can't remember what he said.
Well, that's not good.
Anyway, he'll figure out what he said, and then we'll talk about it, and we'll see if it's sufficient.
Yeah, demanding this shit. Tell us what pressure you require. Tell it to us.
Again, it's his vacuum. He gave a number. He says he can't remember. We'll have to get back to it another time.
Well, he says he doesn't think he ever gave a number. That's what I heard him say.
Yeah, he did give a number. I can't remember what he said.
You talked about it, you know?
I've just said I can't. He can't remember. I can't remember. What's the problem?
All right, then let's do a number right now.
Well, asking him, what does he want? What do you think is sufficient?
Kimo, I'll be honest with you. I think the atmospheric pressure that we exist in is good enough. So it's your call, right?
I think they agreed on 1 PSI probably.
What?
1 PSI sounds right.
Yep. Sounds good to me.
Look, just remove the pressure, remove the cause, and will have no effect. As simple as that.
Captain Ambiguity again.
Let's do it this way, Kimo. Would you agree if pressure is what's causing it, then half pressure would only be half the cause? In other words, if we test it with air pressure in there, full atmospheric pressure, and then we reduce that and see how much movement we get, and then when we reduce that to half atmospheric pressure, you should get
want
half
to do
the
that,
movement,
that's
right?
up to you, but we're looking for cause and effect.
Would you like to? Well, I'm just asking you.
That's up to you, but we're looking for cause and effect. You need to manipulate and wiggle the
Look, that's
cause.
your fucking test. We're doing it for you.
No,
I'm
no,
gonna
no,
send
no.
you a
That's
bill.
extra nonsense that we don't need. We only need the cause, which is the pressure. Remove the pressure, no cause, no movement. Simple as that.
So, hold on.
No, you don't need to.
Hold on, let me ask
Kimo,
you
you
something.
don't.
Kimo, so are you saying there's actually atmospheric pressure?
No, there's no such thing as atmospheric pressure. What are you talking about?
You're pretty much claiming there's atmospheric pressure right now.
No, there's no such thing as atmospheric pressure, Pyro. What are you talking? Where does the pressure come from?
So why do we need to put it in a vacuum chamber if there's no atmospheric pressure?
So there's nothing wrong with the Cavendish done in normal pressure then, is there? Normal atmosphere then, Kimo, if there's no pressure.
Oh my gosh, you're doing it in a in a container which creates pressure, and outside of the container you've got the current, the draft. Exactly.
But
So
when there was no big weights in the Cavendish experiment, there was no movement. We eliminated pressure and movement because there was no movement seen when there was no large weight set there. So we have done that thing. We have manipulated that variable and we have seen that outcome. We have eliminated the possibility of air currents and pressure causing movement in the Cavendish experiment. When we introduce the large masses to the Cavendish experiment, we see movement.
Yep. We expect to see movement.
So we have eliminated pressure and atmosphere from being the cause.
So then why, in a vacuum, doesn't it move?
It doesn't
matter. That's a non sequitur. It's got nothing to do with the fact that we have seen whether the pressure's there. With the pressure, the only thing that causes
you was about to say without the pressure or with
Not
the
a non
pressure.
sequitur. It's a false claim.
You
It's a
see,
false
farmers,
claim
you was
that
about to
Kimo
say
cannot
with
back
or
up.
without the pressure, but you haven't done it
It's
without
an
the pressure, have you?
goddamn lie.
Yeah,
Kimo cannot supply any
farmer,
evidence
you need to make a mistake there.
showing that it does not work in a vacuum.
Yeah,
Kimo should be banned from the motherfucking server.
You should be banned
until
for
he can
wasting
provide
everybody's
evidence
time.
That it doesn't work in a vacuum, as he claimed.
Yeah.
You've never seen it in a vacuum, Kimo.
We've
so
got
why
the
would you
paper
make
curved.
such a
You've not been
dishonest
listening.
statement?
We've got the paper.
You've
We've
never
got
seen it, Kimo.
Never done
You've
it.
never seen it.
Paper.
Kimo.
You got the paper that
Never seen
reports the amount of movement, Kimo.
You can't make any claims about it not working, Kimo. You're a liar from the word go. You're a son of perdition. Satan is your father.
Okay. So look, what we need, like I said, is this observation.
Kimo, everything you need has been done. You said.
No, you heard Farmer's Boy. He said whether
that
it's with the pressure or without, and he paused at without.
Everything you require has been proved.
No, Farmer's Boy said it just now. Farmer's Boy
All
just
the
said
variables
with
that
or
you
with.
require have been manipulated.
No, you just heard Farmer's Boy.
Yep. Everything that you require.
No,
all the
you just heard
manipulations,
Farmer's Boy.
The hypothesis was made that it was air currents or pressure causing movement.
What did Farmer's Boy just say? He
It
just
was set
said.
up and observed, and there was no movement when there was nominal.
No, look, he's run away as well. Farmer's Boy, you see.
Around the experiment, there was no
he won't let
movement.
you speak, will he?
Therefore,
He's run off.
the hypothesis that air and pressure are the thing that cause the movement have been disproven. The experiment can show whether it's the presence of the masses and the masses only that cause the movement. All the required variables have been wiggled. The
Hey, buddy,
demonstration
it's not
is
fun when you get cut off, is it?
genuinely down to just the masses only.
Look, Farmer's Boy ran off. You see? Because he said whether it's with the pressure or with it, and then he realised hasn't been done without the pressure.
It was Kimo.
So if it hasn't been done without the pressure, why are you trying to tell us that it doesn't work? You're a liar. You're making up nonsense that you have no justification for.
Well, show the observation without the pressure.
Don't have to. I've just explained we can show that it is not the presence of atmosphere that causes the movement in the Cavendish.
The only way to prove that is by putting it in a vacuum
It's not.
and showing
We have proven it. We have proven it. The apparatus sits there with no movement whatsoever when the large balls are not present. There is nothing. There is no movement. There is nothing in the normal situation of the apparatus sitting there in a normal atmosphere, the everyday surrounding atmosphere. There is no movement. It can be observed for hours on end. There is no movement. Therefore, the presence of atmosphere is not the cause of any movement.
There's no movement. What are you talking about? Once it starts moving, Bazaar.
Please try and cut. Please
oh
try.
Oh my gosh! Now try to pay attention. You've just waffled on.
Please try and follow what
you're not letting
I'm
anyone
saying.
talk, Bazaar. I'm going on mute because it's just the Bazaar show. Okay, I can't even respond to your point. I can't challenge you.
I'm on for the first time in 2 days, but suddenly the channel's mine all the time.
Right, the Bazaar show. I can't challenge what you have to say. You mute me. Fundi mute me.
I'm not taking over
again.
the
Fundi mute me. Don't let me speak because you know what we have to say is the truth, Bazaar. You see? You can't handle it. So I think that's enough for tonight, and we can continue. Obviously, this. And just look, BioDuel is the guy, going to be the guy once he provides this experiment. There'll be no more talk about forces, not a force, is a force. You've got the experiment, you've got the force.
Promise.
Absolutely. Promise. Oi, there's no comeback from this, Chaiki. What comeback can there be? You've got your variables accounted for.
You'll think of something, I'm sure.
Well, let me tell you, BioDuel is not going to do it. As in the... What I mean is he'll do it, but he won't. I don't know if he'll do it or not. But what I mean is, if he does do it, he won't see a traction inside the Cavendish. Is what I'm getting at. So you need to prepare yourself, Chaiki, for flat Earth, for no tides being affected by the moon. Prepare yourself for what's to come, because this is a guy who makes promises. Last year, Chaiki, last year, we're now month 4. What do you think this guy going to do magic that anyone else? Come on, think about it, right? So you can wait a year, you can wait 2 years, whatever you need to do, but you're not going to see it in a vacuum. No chance, no way.
Well, I'm not going to see Bev's observation either.
No, none of us are. Nobody will ever observe mass attracting mass inside a vacuum. They'll write about it, yeah, sure. They'll talk about it. Oh yeah, we did it. Yeah, let's write about it. But the actual observation in a vacuum will never be observed. And that's how powerful this simple question is. Is it something that you guys should have already? Time and time. Look how many outside of the vacuum Cavendish we see. Loads, tons. But inside the vacuum, not one. Until BioDuel. So we'll leave it at that for now.
You keep lying about this, Kimo.
I thought you were going to leave, Kimo. What the hell?
Blue, I wanted to ask you, fiberglass would be good as a quartz wire?
Glass for the wire? The torsion?
Fiberglass, yes. For a small mass.
I think it might, I think it might work. Oh, a small mass.